And this is just a slide of one of these pilots what we have had in Sweden with high-capacity vehicles. And now, short, what we have done for a lot of years now, we have had this high-capacity transport program here at Closer, and it is 10 work packages. And I think maybe half of them will be presented here. Something from half of them will be presented at this conference today. And here now is something what has already happened in Sweden since we started this program. And when we started in 2012, it was 60 ton and 25 meter long vehicles what were allowed. 2015, this was raised to 64 tons. And 2018, it was raised to 74 ton on some of the roads in Sweden. And you will hear more about that later from Kenneth Nathanaelsson. And what we still are waiting for, it is a decision about longer vehicles, so 34.5 meters. Sometimes we call it duo trailers or EMS2 if you are more from a European side. And you will also hear a little bit more about that later. And here's also some other important steps that have been done in Sweden. We did a roadmap 2013 because we thought we needed to find out which was the most important questions we need to find answers on. And we also had an updated roadmap 2019, which was not so maybe big as the first one, but I think still it was important to see what we need to do if we should reach our goals. And in between, we also have had assignments from the government about high-capacity transport, and the first one was 2015, and the last one was presented 2019. And maybe the most important thing that has been used from this high-capacity transport program is what we introduced, like performance-based standards in the vehicle regulations for 74 tons. So that we could see real use of all the things what we have done in our research program. And I think always that is the main thing you should try to reach. It is that it's also introduced in reality, not just research. Now I will just shortly go through the program. So in the beginning, we will have something about future trends from different sides, both from the Swedish Road Administration and the Swedish Parliament, Anders Åkesson. And then we will have some also outside the Nordic countries. We used to have at least one, and now we will have two different speeches from both actually from Netherlands, both about intelligent access from an international perspective and also experiences from EMS2 research in Netherlands. Then we have what we all have had every year, what is happening in high-capacity transports in each Nordic country. And I think that is always interesting to have an update on. And in the afternoon, it's more about different projects, what have been done. So we will have both from Sweden, Norway, Denmark, and Finland, different projects where we present what we have done. And we will also have, we thought it was in the end important to, because we have requests for new rules for overloads and BK4. It is 74 ton introduction in Sweden that Per Ekström will have. So I think you shouldn't leave the meeting until the last speech because it will be really interesting speeches in the end. Also Otto Lahtis about intelligent boogies, because if you want to use these longer vehicles like 34.5 meters, you need to find solutions to have it working in the best way. I think that was quicker than I expected. So it's still 3 minutes left, but I think you will usually lose some time later. So Jonas, if you are prepared, because I think it can be some extra questions for you and also Anders Åkesson after you. So please, you can start.
Certainly.
With this, and
I'll do that.
Yeah, and Jonas is director at this. You can present yourself more at the Swedish Road Administration. So I'm really glad that he can take part here and do this presentation. So please,
thank you,
Jonas.
Thank you. Nice to be here. And let's see. With a little bit of luck, you should now see a nice logotype from Trafikverket, a nice red sign, right?
Yes, but is it his? You can see his presentation now. Yeah, it's right.
Yeah, very good. So this is the title of this of the presentation, right? Yeah, hopefully this. Okay, so the topic of today is overly ambitious, of course, the past and future of domestic freight transport. And of course, I won't be able to cover everything that can be said about this. But my main point is, I think the main sort of the outline of this is that I think it's important to think about what changes that are occurring now that really are game changers and what ones are more of a transient nature. I mean, someone once said that it's easy to overestimate the changes in the short term, but underestimate the changes in the long term. And some of the things that are new, we tend to overestimate how much they will actually change things. But on the other hand, some very long-term trends, we have the tendency of underestimating how things will actually change. Now I'll just try to, in my brief time here, make a couple of brief reflections or maybe speculations about what I think are the main changes, and also actually say something about what I think will change maybe less than some people, at least sometimes, say they think will change. And as Thomas said earlier, I'm Jonas Eliasson. I'm the Director for Transport Accessibility at the Swedish Transport Administration. I'm also a part-time professor of transport systems of Linköping University. So my main background is being a researcher in transport systems. So, of course, the biggest change and the biggest challenge that we see ahead is getting to a fossil-free transport system. Now, the good news is that electrification seems to be going faster than we thought just a year ago, actually, just a couple of years ago. And this applies in particular to the heavy vehicles. When it comes to light vehicles, we are roughly on track with the forecast that were made a couple of years ago, at least to the more optimistic forecast, actually. And much of this is governed by the challenging but probably reachable EU carbon emission vehicle standards. And I'm sure that you all know about these. These are challenging. These put lots of challenges to especially the vehicle industry. But it seems to be that they're actually reachable. So even if they will certainly require substantial investments in new models and new production lines and so on. But this also means that we have a fairly good grasp of what the future vehicle fleet will look like, as opposed to many other things that are more uncertain. Now, I would say that the probably most challenging thing and the most uncertain thing is developing good charging infrastructure. And again, this applies in particular to heavy vehicles. When it comes to charging infrastructure for light vehicles, most of the charging will be made at home anyway, or possibly at the workplaces. And developing and producing charging infrastructure for light vehicles, that's also a substantial challenge. But even that large challenge is lower than the same thing for heavy vehicles. And that's because of two things. One is that it requires so much more effect, so much more power to charge heavy vehicles. And it's also that the amount of chargeable heavy vehicles on the roads and on the streets will, for some time ahead anyway, be so low, so it will be hard to have commercial viability for charging infrastructure in the short term, at least the next 5 or 7 or maybe even 10 years. And that means that the governments need to have some kind of responsibility for making sure that charging infrastructure is not a bottleneck for developing chargeable vehicles, because otherwise it would be essentially impossible to reach the European emission vehicle standards. Because if you don't have any charging infrastructure, very few people will risk the investment of buying a chargeable truck, for example. Now, another good news is actually that it seems to be that static charging, that is charging when the vehicle is standing still, seems to become more and more efficient compared to dynamic charging. And dynamic charging has, that is when you charge on an electric road, for example, so you charge the vehicle while it is moving. Now, dynamic charging has many advantages, it has many benefits and so on, but it's relatively expensive to build, and it also requires some investments in the truck, so for example, and the increased capacity of batteries seems to me that the static charging will become, relatively speaking, more and more efficient. And that's actually good news, because static charging is, even if it's expensive, it's relatively cheaper than dynamic charging. So we will most likely have dynamic charging as well, but it seems that we will need not as much of it than we thought just maybe a year ago, maybe 2 years ago. Now, the big problem is that replacing the vehicle fleet takes time. An ordinary truck lives for quite some years. Depends on what truck you have, maybe 10, maybe sometimes even 20 years. And when it comes to passenger cars, they live for roughly, almost 20 years. So replacing the vehicle fleet takes time. So it's hard. Even if electrification now goes very quickly, it's still not enough to reach the short-term climate targets, the targets that we have for 2030, for example, in Sweden. So, and this diagram shows this. Let's see here. On the left, you have the carbon emissions per kilometer for both for new heavy vehicles and new passenger cars. And as you can see, they are going down really quickly. But on the right-hand side, you see the corresponding carbon emissions per kilometer for the whole heavy vehicle fleet and for the whole passenger car fleet, weighted by kilometers, by model, and by vintage of the car, that is the age of the car. And as you can see, they're also going down, but they are not going down quickly enough to reach the 2030 target. And the Swedish 2030 climate target for the vehicle for the transportation sector is a 70% reduction relative to 2010. So these are, as I said, these are good news, but it's still not enough to, on its own, reach the 2030 target. So this is a realistic but ambitious scenario of how the Swedish climate targets for the transportation sector can be reached. And as you see, we are now comparing with now, which is 2021, and this picture starts in 2010, which is the year to which the 2030 emissions are compared. And as you can see, better fuel efficiency makes up a significant portion of this. And this is because even for a very long time now, vehicles have become more and more efficient. And this is now gradually being complemented by a higher and higher share of electrification. But as I said earlier, it takes time for the fleet to be replaced. So especially in the medium term, that is around 2030, the share of fossil fuel that needs to be replaced with biofuels goes up. And this is well, the good news is that biofuels can be replaced in existing vehicles. The bad news is that the supply of environmentally and sustainably produced biofuels is limited. So it's hard for a country like Sweden, for example, to be a model for the rest of the world if we base our climate policy for the transportation sector to a too high extent on biofuels. But to reach the 2030 target, it's necessary to replace a significant share of fossil emissions, fossil fuels with biofuels. Actually, it doesn't show this so much on this slide, but the absolute volume of biofuels compared to today probably needs to increase by 70% just in Sweden. And it's already the case that Sweden uses a very high share of the global supply of biofuels. So this is definitely a problem, but it's hard to see any other realistic way to reach the 2030 target in Sweden. Now, the good news is that even if we limit ourselves to only using the same volume of biofuels as we do today, then we can still reach the 2030 target, but a little bit too late. We can, well, maybe it's wrong to say that this is actually good news, but it's still the case that we can reach the 2030. We can almost reach the 2030 target, even with using the same volume of biofuels as we do today. We reach the 2030 target by 2035. The new biofuel mandate decided by the government just a year ago, that mandate is actually enough probably to reach the 2030 target. But even if we, for some reason, later decide that maybe this was too expensive, or maybe the supply of biofuel was lower than we thought, it's still possible to reach the 2030 target, but maybe a little bit too late. So these targets, they are actually possible to reach, and paradoxically enough, perhaps it's actually easier to reach the 2045 target of full fossil free transportation sector than it is to reach the 2030 target. And the reason for this is that by then, by 2045, we will have been able to replace a very high extent, very high share of the vehicle fleets by electrified vehicles. So another challenge then, online shopping. Well, I would say that online shopping presents a huge challenge to the logistics sector, but it's a challenge and a change in scale rather than in kind. And what do I mean by this? Well, we've actually had things like mail orders, for example, for a very long time. The Swedish firm Clas Ohlson established its mail order firm in the early 20th century, actually back in 1910 or something like that, maybe 1915. And what we do now is that we are scaling up the same qualitative kind of system as we already have. So we need to design those kinds of systems so it's capable of having higher capacity than it used to be when the volume of retail going by being bought online is higher than it used to be. As we speak right now, online shopping is about 14% of total retail volumes, measured in crowns, I should say, measured in money. In 2030, most people speculate that it will be around 30%. This is, of course, a speculation, but it says something about the increase in volume that we're seeing for the next decade or so. And we're also seeing a higher and higher demand of people wanting deliveries right to their doors for groceries, for example, or for certain other goods as well. This means that volumes will become much harder, and that also puts a large challenge in the capacity of the transportation system. But on the other hand, as I said earlier, the basic organization of these logistics systems capable of doing these things is actually not that different from the system that we already have. If I simplify this a little bit, it's relatively easy to increase capacity in most parts of this logistics system. Apart from, of course, from for example, delivering in the most dense urban cores, for example. But in large parts of these logistics systems, there is actually either spare capacity as we speak, or it's possible with moderate investments to increase capacity as well. I would actually think that from a transportation point of view, the biggest challenge of online shopping is something else. And when I turn to this one, I actually hope that I'm wrong, because I believe that online competition will have the tendency to fuel suburban malls. And suburban shopping malls, they are actually one of the biggest problems with especially local and regional traffic planning, because it's for one thing, it makes it necessary to own a car to do your basic grocery shopping, and it also creates more traffic, creating externalities and congestion and emissions and so on. And the reason why this tends to be the case, it's it's very hard for physical stores to beat online prices and online supply. So what physical stores then need to do is first to reduce costs and also to increase their product range. And these suburban supermalls, it's actually, they are the answer to those things, because not only is the rent that you pay for your store lower when you do it suburban. That's actually not as strong argument, but the really strong argument is that you have a much cheaper logistics solution when you have one of these big super malls. Because what happens is that you actually have you turn your storage into your warehouse, so it's possible to operate one of these huge stores with a very limited staff, and that again cuts cost. You reduce the cost for bringing the stores from your storage to the actual store. And it's also possible to have a much larger product range, which also is a very important competitive advantage for online supply otherwise. Now, I think that most of us, at least me, we like the traditional inner city. We like things like in inner city retail, being able to walk everywhere and to look in stores. And it's a very nice experience. And it's possible that inner city retail may try to compete being a nicer shopping experience. But I hesitate whether that would be enough to meet the competition from online shopping and from these suburban supermalls. Because if you think about it, I mean, when the supermarket groceries arrived in the 1950s and 1960s, we had over the counter shopping was the competitor. And well, I think it's true that over the counter shopping, the really traditional conventional store, which you probably played when you were a kid, when you hand over things like this over the counter. That's a very nice way to experience shopping, but it takes much more time. It has a lower product variety. It's much more expensive, and so on. And we have very little of that kind of shopping left. So even if I think it's true that inner city retail is a much nicer, much better shopping experience, I have this fear that it might not be enough to meet the competition from super malls and from online shopping. I really hope that I'm wrong. I should emphasize this. I hope that I'm wrong, but I'm worried when I see this development. Well, when it comes to transport efficiency, then, well, this is a transport efficiency conference, and maybe I should take the last bullet point here first. I think that there is a significant potential when we talk about allowing and enabling heavier and longer vehicles. And maybe this goes without saying. I mean, think about this particular audience, this particular conference. But I think we should need to remind ourselves that the benefits of allowing and enabling heavier and longer vehicles is that it both reduces costs for the customers, costs for the transporter, and so on, but it also simultaneously reduces emissions and wear and tear on the road and accidents and so on. That being said, there are also people believing that there is a great potential for making other kinds of transportation more efficient, for things like higher load factors in existing vehicles and so on. The thing is that logistics planners, they are generally smart people. And I think that it is rather unlikely, actually, that substantial efficiency gains would go unnoticed, because they are working with this their whole professional life. There is certainly some things that we can do, for example, ubiquitous sensors giving ubiquitous information that can facilitate co-deliveries and co-logistics, which will tend to increase load factors and so on, and a better matching of transportation demand and the available capacity. But we should also remind ourselves that this idea, this business idea of matching capacity with supply and organizing co-logistics where several customers use the same transportation or logistics patterns, that's actually already the basic business idea for many transport companies. Things like Schenker and so on, and Green Cargo and so on. They work with this. This is their basic business idea. And the idea that there are huge capacity going unused, I think, is a little bit naive, actually. I think there is definitely room for making some efficiency gains here, but believing that this will have a large effect on total transport volumes is, I think, over-optimistic, actually. Now, speaking of things that are on the table right now, we actually handed in the Swedish or the proposal for a new Swedish infrastructure plan for the next 12-year cycle the other week. Some of the main things that need to be emphasized again is that we urgently need more money for road maintenance. Our road system is right now in a rather bad shape, and it's becoming more and more worse. And the funding that we have is not enough to even keep it in the shape as it is right now. We also emphasize the benefits that are there for allowing and enabling heavier and longer vehicles. Most of the investment is earmarked for railway. The high-speed railway network is a very big share of this, and also the new signal system, ERTMS, is also a big investment here. So it's actually very little. Only 15% of total investment volume goes to roads. And that's investment. So we differentiate between maintenance, just keeping things in shape as it is, and investment, which is develop new functions, building new stuff, and so on. There is almost, not quite no room, but almost no room for new investments actually, because the previous plan used up quite a large share of the budget for this planning period as well, and then together with the increased costs for especially the new investments means that there is very little room for new investments. One of the worrying things with the new investment plan is that it actually takes up quite a lot of the planned budget also after the planning period. This is planned investments for right now. We are starting here with, let's see if I have a pointer, laser pointer. Yeah, so right now we are here. So this is then the average annual budget for the next 12-year cycle. And you can see that right now we are planning for a little bit, we have a little bit money to save, right? I mean, a little bit money left here, and we are need a little bit more money here, but we can sort of then shuffle around some of the investments so we meet the average annual budget. But the problem is not the current planning period up until here. The problem is afterwards, because we are now planning investments that are actually higher than the current annual investment budget. So either we need to change things over here and spread these things over even more over time, or we need even more money after 2033. So this is a sort of a structural problem of the Swedish investment planning, that we have the tendency to plan for more money than we actually have, even after the planning period. Now, another thing then, which is also well, something that might change, but also something will not change as much as people believe. Perhaps. Let's see. I'm trying to get rid of my laser pointer. So this is the modal split of domestic freight transport, both historically since 1970 and also the forecast. Despite the fact that we're investing so much in new railways, and actually especially in new railways that open up for domestic freight transport, the modal split doesn't seem to be changing a lot. It does change a little bit, but not so much as some people perhaps hope. And the basic reason for this is that there is such a large share of domestic freight transport is freight that is more or less bound to one particular transport mode. So even if we increase capacity of railways, for example, we are not moving so much such a large share from road to rail and sea. There is some effect, but that effect is actually not so much, and that's also one of the constants of domestic freight transport patterns. I actually need to stop here. So now I presented some things that are actually changing, for example, fossil-free transport, which is in a sense more of a challenge to the vehicle industry than it is for the transportation industry. Because if you're a transporter, the characteristics of your vehicles will change, but the basic transportation patterns tend to remain quite similar to what we see today. Now my time is up, so I need to stop here. Thank you very much for your attention.
Thank you, Jonas. I think it's 10 o'clock, so I think we don't have any time here for any questions. So I would like to have a next speaker. Now we first had from the road authorities side what we think are the biggest challenges, interesting trends in this area. And now we will hear something from the political side. So I'm very glad that we can have Anders Åkesson from the Swedish Parliament. Will do his speech about the same area as Jonas just did. So please, please, if you're standing here.
Thank you.
I heard you have some problems with a late train, so but
yes,
you should be here. If you should be in the camera, you should stand close to this cross.
I have to stand on the cross. Thank you so much. I will wear my cross. Thank you so much for invitation to this conference, where I should try to give you a picture of the political context about high capacity transport. And I will continue in Swedish because you have to try to understand, and of course I will give you answer if there are any questions. And I have no pictures because I was sure, I think, and that it was right, that Jonas have very good pictures about the thing we are talking about. Tack för möjligheten att få komma hit, och jag är ledsen att jag stressade upp det lite, Thomas, med att jag kom just in time, men det är ju så det ska vara. Jag hade givetvis tänkt mig lite mer tidsmarginal, men på grund av snö och hård belastning så var järnvägssystemet hårt pressat här på västkusten. Men det redde sig. Och jag heter då Anders Åkesson och är en av 17 riksdagsledamöter som sitter i riksdagens trafikutskott. Och det är ett av riksdagens 15-16 utskott inklusive en EU-nämnd som då specifikt jobbar med den nationella politiken och trafikfrågor. Och då är det de 5 transportslagen: väg, järnväg, sjöfart, flyg och post och IT. Mer IT än post. Och dessutom har trafikutskottet ansvar för tiden. Och det kan man ju undra, varför har trafikutskottet ansvar för tiden, Thomas? Säg det. Det är en historisk orsak. På den tiden man byggde ihop landet, den har med transportinfrastruktur att göra, på den tiden man byggde ihop landet i ett enhetligt järnvägssystem så behövde man ha en enhetlig tid. Att klockan var 10.03 i Göteborg och samtidigt var det i Stockholm, annars skulle inte man kunna utnyttja systemet på ett logistiskt effektivt sätt. Och då hamnade ansvaret för tiden i riksdagens trafikutskott, för det var också på den tiden riksdagsstrukturen skapades och frågorna skapades, och järnvägen var det nya hypade transportslaget. Innan dess hade ju inte klocktiden spelat någon vidare roll om den gick en kvart före eller efter i Alingsås jämfört med Göteborg. Det spelar liksom ingen roll, men när man knöt ihop det så blev det viktigt. Sjöfarten var lite tidigare. Vi ägnar inte så mycket tid åt tiden, ska jag säga, men den finns där. Ja, just det. Och i akademiska sammanhang brukar man ju prata om en kvart. Men så vidare. Tack för inbjudan, och jag har haft kontakt med många av er genom tiden och arbetet kopplat till High Capacity Transport. Thomas här, Lennart Sider, Lena Larsson, Per Olsson, några av er är i lokalen och några kanske finns ute i cyberrymden. Och det har varit väldigt spännande att följa. Jag tänkte ge en liten roadmap, liksom var befinner sig frågan på den politiska himlen. Varför är det ens en politisk fråga? Och sen ska jag landa lite i det som Jonas Eliasson slutade med och uppmana er att vara lite rebelliska. Det Jonas på 2-3 bilder redovisade, det är alltså en rapport på 213 A4-sidor med en förskräcklig massa underrapporter, förslag till ny nationell transportplan. Som alltså ska styra Trafikverkets användande av nästan 1000 miljarder kronor. För det blir det, Jonas, om du lyssnar nu. Ni fick med er nästan 800 miljarder, 900 miljarder i ett riksdagsbeslut, men sen kom det rätt mycket medfinansiering under resan. Och hur det ska användas på ett transporteffektivt sätt för att vi ska uppnå klimatmål, transporteffektivitet och så vidare. Där är jag säker på att ni kan bidra väldigt mycket. Men vad har då High Capacity Transport och det ni jobbar med att göra med politiken? Ja, det är väldigt många sammanfallande mål. Väldigt många sammanfallande mål. Det är klimatnyttan och klimatavtalet, klimatåtagandet, Parisavtalet, senast nu i Skottland, uppföljningen på det. Det är svenskt näringslivs konkurrenskraft, förmåga att konkurrera på en världsmarknad. Fordonen ni tillverkar här i Göteborg, eller hytterna till fordonen som tillverkas i Södertälje, som vars hytter tillverkas hemma hos mig i Oskarshamn, går ju till 97-98% någon annanstans i världen. Skulle de stannat i Sverige hade det varit fullt av Volvo och Scania-bilar här ute överallt, och det vill vi ju inte. Alltså svensk industri är ju extremt export- och handelsberoende, och svensk näringsliv totalt sett. Det handlar om ordning och reda. Tänker vi tillbaka lite på en del motsvarande high capacity transport-idéer som har förverkligats i Sverige över tid och längd, så har vi alltid haft lite längre, lite tyngre och lite högre landsvägsfordon och i någon mån även järnvägsfordon, men framförallt landsvägsfordon. Det har givit svensk industri en konkurrensfördel och också svenska åkerier i någon mån en liten konkurrensfördel, därför att man kan ta igen långa fysiska avstånd med en effektivare transportmetod. Det handlar om en ambition att hela landet ska leva. Då måste vi vara transporteffektiva för att vi ska överbrygga långa geografiska avstånd. För någon dryg vecka sedan var jag på ett motsvarande möte fast i Luleå. Då var det handelskamrarna i Västerbotten och Norrbotten som har bjudit in till en, inte high capacity transportkonferens, men en konferens för att försöka illustrera vad händer när man investerar 1007 miljarder kronor industriellt i norra Sverige. Vilka förväntningar ställer det på transportsystem, vägar, järnvägar, sjöfart, samhällsbygge, utbildning, arbetskraftsförmåga och så vidare. Det vänder ju liksom bilden lite av hur många av oss har varit vana att se på ett avlångt land. Transporteffektivitet och kundnytta med mera. Vad jag vill hävda är att ni är ju verksamma i det här projektet, Thomas och vänner. Ni är ju precis mitt i brännpunkten på en jättestor samhällsfråga. Det är jättemycket teknik. Jag vet när Lena Larsson ringer upp mig så är det axelkonfiguration och detaljer och jag är lost på 3 sekunder. Rätt att jag är maskiningenjör en gång för många år sedan. Men ni måste på något vis arbeta upp i den lösningsorienterade delen av samhällsdebatten, därför att ni sitter ju på svaret på många av de samhällsutmaningar vi har nu. Rätt mycket av det som Jonas Eliasson beskrev. Och sedan, jag har inte suttit sedan järnvägens tillkomst i riksdagens trafikutskott, men ändå rätt länge. Och på den tiden har ju high capacity transport gått från att inte ens vara omnämnt, vill jag hävda, i de betänkandetexter som trafikutskottet har fram, till att idag vara omnämnt under egen rubrik. Ni har klättrat. Och det är inte min förtjänst, utan det är förtjänst flera partier, alltså de här 17 ledamöterna företräder olika partier proportionellt till riksdagens totala sammansättning. Lyfter frågor om längre, tyngre, mer transporteffektivitet, samverkan mellan transportslag idag än vad man gjorde tidigare. Vi är inte i mål, men frågan har klättrat. Och det är bra. konkret så började resan väldigt mycket med BK4. Alltså vilken bärighetsklass har vi på statens vägar. Och det i sin tur bygger på en förordning eller en lagstiftning från millennieskiftet där man graderade upp det från BK3 till BK1, alltså 1 är den högsta. Och det byggde då på 64 ton totalvikt, och det kan ni mycket bättre än vad jag kan. Initialt var det väldigt mycket skogsindustrin ihop med fordonsindustrin som drev frågan, som lyfte in den i politiken. Den har kommit att breddas. Och idag är det ju inte minst fler branscher än skogsindustrin som är beroende av high capacity transport. Vi behöver bara titta strax utanför centralstationen i Göteborg. Nu förlitar jag mig på att Lennart Sider är en sanningsenlig man, men någon gång, och det har du aldrig svikit, men någon gång, jag tror det var du Lennart som sa att med BK4-standard, alltså den lastförmågan i ett sådant bygge, så skulle antalet fordonsrörelser kunna reduceras med runt 20% Ja, det betyder rätt mycket i en tätort som Göteborg om runt 20% färre tyngre fordon kan utföra samma transportarbete som det innebär att bygga Västlänken. Det är kanske där de allra största störningsvinsterna är. Och det är genom att då engagera fler branscher som bygg- och anläggningsindustri, Trafikverket som är faktiskt en av de absolut största beställarna av bygg- och anläggningsarbeten i vårt land, att engagera sig i frågan. Och då kommer ju nästa utmaning. Då är det ju inte statens vägar vi susar runt på. Då är det Göteborgs kommuns vägar eller Alingsås kommuns vägar eller till och med enskilda vägar i en kedja av vägar där statens några tusen mil till hög utsträckning, hög bärighet, bara är en länk i en kedja. Men finns inte den sista länken, då blir det ju ingen effekt. Frågan har inte blivit lättare för att ni har engagerat i den, men så är det ju ofta när man börjar rota något som ser rätt enkelt ut, att den breddas. Men det är bra att fler engagerar sig. Statens vägar då, de som Jonas är anställd för att ha kloka tankar i och gör politiskt engagerad då som ett delmål då, som egentligen den här då förslaget till ny nationell transportplan tar mycket fasta på. De är ju i mycket hög utsträckning av en hög bärighetsklass. Man har som mål att 2023 så ska så mycket som 40% av det statliga vägnätet ha bärighetsklass 4. Och man säger redan idag då att runt 99% av transportarbetet går på vägar med mycket hög bärighetsklass. Och då skulle det kunna vara fritt fram för fordonstillverkare, åkeriägare, godstransportköpare att ja, men 99%, vad är det? Vad sitter ni där i Göteborg och oroar er för, Thomas? Det är ju klart. Det är väldigt lätt att lura sig. The last mile saknas ju ofta. The last mile kan ju vara ut till en hamn på ostkusten, en bit kommunal väg som i min vackra hemstad Kalmars fall. Riksväg 25 mellan Halmstad och Kalmar. Som en tung del i det svenska vägsystemet, en del i stomvägnätet. Där en bro över den vackra Slottsfjärden, 1 kilometer innan Kalmar hamn, är den begränsande faktorn för att ha BK4-klass ända ut i hamnen. Ja, det räcker. Jag tror den har ett spann på 5-6 meter. Jag kommer under den med min lilla båt. Men det räcker. Det är en detalj, och det är ofta detaljerna som är viktiga. Och då kan man säga att det är de här flaskhalsarna, the bottlenecks, som måste identifieras och åtgärdas. Och hur blir det då möjligt? Det är ju inte statens väg, det är ju Kalmar kommuns väg, och det finns 290 kommuner i vårt land, och det finns tusentals vägsamfälligheter i vårt land, och det finns väldigt många industrivägar i vårt land. På något vis måste ju helheten engageras. Det blir inte lättare, men det är fullt nödvändigt. Låt mig göra en jämförelse. Västkustbanan som går, alltså järnvägen, Jonas beskrev ju hur det har lagts och läggs väldigt stora pengar på att reinvestera och investera i järnvägsinfrastruktur i vårt land. Västkustbanan har ju under decennier investerats gigantiska pengar i. Jag tror, och nu killgissar jag, runt 150 miljarder kronor över mycket, mycket lång tid. Men den fulla kapaciteten av den mycket stora investeringen, det handlar ju om en 20 år, går inte att ta ut. Därför att bitvis är banan enkelspårig. Strax norr om Helsingborg finns en station som heter Maria station, där det är enkelspår. Genom Varberg är det i princip enkelspår. Hallandsåsen, som ofta är bespottad då som ett onödigt tokigt projekt och som kostade för mycket. Ja, misstaget var det att man hade inte analyserat berget eller bristen på berg. Men själva åsen innebar att det gick inte att köra fullastade godståg mellan Norge och ner på kontinenten, för de tog sig inte över åsen. Och då får vi inte ut, trots att man investerat då gigantiska belopp i ett system, så var det flaskhalsar. Och det är precis likadant med vägarna. Så fort det räcker med en bro i Kalmartrakten för att sträckan Halmstad-Kalmar ska vara blockerad för en genomgående tung transport. Och då måste man engagera. Och det har tagits rätt mycket politiska initiativ, och det är att försöka få Trafikverket att steppa upp som myndighet och bli mer rådgivande gentemot de 290 kommunerna i första fall. Att hjälpa till att klassa broar, hjälpa till att rådge och sitta på kunskapen. Du får hosta till redigt, Thomas, när tid.
Ja, det är 3 minuter.
3. Vem vinner då på high capacity transport? Initialt var det väldigt mycket skogs- och fordonsindustri som drev det. Men jag vill säga att det är hela samhället, givet de här övergripande initiala målen. Lyckas vi med detta så kommer vi att lösa ut eller göra entré till den väg som löser mycket av de utmaningar vi har sagt vi måste lösa kring klimat, effektivitet, hela landet ska leva. Det har hänt rätt mycket sedan 2001 när man klassade BK1. Det kom en proposition 2017 som öppnade för BK4. Det bildas en godstransportråd eller lades en sådan strategi 2018 som öppnade upp för samtal mellan företrädare och staten hur man skulle kunna effektivisera. Den här där jag skulle vilja uppmana er då att ta plats i rummet. Det är ju alltså ett förslag till ny nationell transportplan för åren fram till 2033. Den handlar om hur 900 miljarder, kanske 1000 beroende på hur mycket medfinansiering och EU-pengar som kommer in, ska användas för att vidmakthålla och utveckla det svenska transportsystemet avseende stora hamninvesteringar, vägarna och järnvägarna i all huvudsak. Här talar man rätt mycket. Man talar varmt för längre fordon och säger att det är en stor samhällsekonomisk nytta i att ha längre fordon. Man talar om ambitionerna kring BK4, men är de tillräckliga? Häromdagen, och det här vill jag att ni, vad ni nu än företräder, måste engagera er, för ni sitter ju på kunskapen, detaljkunskapen och de större sammanhangen i detta. Den här presenterades på Andersdagen den 30 november. Det pågår remiss till och med den 28 februari. Remisserna sänds, tror jag, till infrastrukturdepartementet. Det framgår om ni går in och rotar fram den. Sen kommer det vara en period mars, april, maj, kanske juni, när det är en intern beredning på regeringskansliet, infrastrukturdepartementet. Sen fattar regeringen beslut en kall torsdagmorgon på försommaren. April-maj. Ni ska vara på som iglar, bidra med kunskap genom Västra Götalandsregionen eller var i landet ni nu befinner er. Jag vill sluta med en game changer. Någonting som hände den 25 november. Då uppvaktade Sveriges åkeriföretag tillsammans med tågföretagen riksdagens trafikutskott. De kom samtidigt. Och det var lovsång i mina öron. Därför att de rev det här plåstret att det på något vis alltid är att om det går bra för dina järnvägar så går det dåligt för mina vägar och vice versa. De beskrev sambandet. Det är ju liksom en bugg i det politiska tänkandet att det finns fina eller fula transportslag. Det begriper ju alla som är i det här rummet och till äventyrs i webben att en transport är ju från dörr till dörr och omfattar väldigt ofta väldigt många och olika transportslag. För att prylen eller människan ska komma dit den ska. De var väldigt tydliga, företrädarna för Sveriges åkeriföretag och tågföretagen. Och jag vet att sjöfarten och godsflyget knackar på dörren hos dem för att få ansluta sig. De hade en kravspec, ni kan hämta hem den på deras hemsidor, där de talar om det intermodala sambandet mellan olika transportslag, behovet av effektiva omlastningsterminaler, mötesplatser med full bärighet så att långa tåg, långa lastbilar, tunga tåg, tunga lastbilar, tunga sjöfordon, sjöfartyg kan mötas och göra den här sömlösa resan effektiv. Och då behövs era high capacity transport lastbilar och motsvarande teknologin på järnväg och sjöfart och flyg. De argumenterade med samma goda argument som politiken använder: konkurrenskraft, klimat, ekonomi, och pekade på behoven som ni gör och många andra. Terminalmötet, den last mile-problematiken och så vidare. Jag tror att det låter stort att säga att det är en game changer. Men det är faktiskt första gången branschorganisationer för till normalt sett man ser som konkurrerande transportslag sätter sig ner, enar sig om ett tvåsidigt dokument eller om det var 3 och politiskt uppvaktar och säger det är så här det fungerar. Sluta tjafsa att det är en dum konkurrens eller en onödig konkurrens. Vi samverkar, transportslagen måste lösas. Och dessutom lyfte åkeriföretagen detta som en konkurrensfördel för den typ av åkeriföretag som sköter sig, har rimliga sociala villkor och betalar löner och skatter och hänger med i utvecklingen som Eliasson beskrev, att ställa om. Därför att om man samverkar, tar bort de långa transporterna som åkeriföretagen har svårt att rekrytera personal till, sätter dem på tåg och låter gummihjulen sköta radien runt omkring väl utbyggda terminaler. Det är så det funkar redan idag. Men då behöver terminalerna få plats i Stockholm, Göteborg och Malmö så att mötet uppstår. Eller om det är Borås som ni senare ska titta på. Tack Thomas!
Ja, tack så mycket. Anders, now I take it in English and also for the next speaker. That I will use 5 minutes of the hours we have later because I need to ask you one question.
Yes.
We have a change with a new government now. What do you think that will affect the possibilities to introduce longer vehicles in Sweden? Maybe it's difficult for you to answer, but if you have something to say, so please, short.
That's not easy. How? That's because the cross.
Cross, exactly.
I see. There's a camera somewhere.
Yeah, there.
Oh, thank you. I hope so. I hope so. And I hope that... yes, I think so.
Yeah,
I will
good.
stop there.
Yeah.
Because it will be just speculation and that's nothing. But I think so. I think the door is open. The window is much more open now than before this government change, Thomas.
Yes.
So it is.
Yeah.
The forbidden things
Exactly.
is gone. Oh. Yes.
Yeah, thank you again. And now we will go back to have a speaker online. So please, Loes Arts from the Dutch Ministry of Infrastructure and Water Management. And yes, I can see you.
Yes, can you hear me also?
Yes, could you have it in presentation mode? Yeah, perfect.
Yes.
So you can just continue. We can see.
Okay. Thanks a lot. It has been 2 years ago since we were in, almost 2 years ago, since we were in Helsinki. And some of you were there also. We were talking about the EMS2 vehicle combination. I still have good memories on that trip. And it was just before Corona started. So we couldn't imagine what happened in 3 months after that. I'm not going to tell something about high capacity transport. In those 2 years, a colleague of mine, Rick Smits, is my successor on this topic, and he will tell about high capacity transport in the Netherlands after the break. But I'm going to say something about intelligent access from an international perspective. I'm going to say something in general about access policies. I will go through some examples in Europe and in Australia. And then I will talk about some important topics in the context of intelligent access. So this slide, what you see is a production location of synthetic dyes made from coal tar. This is well, this is not the 19th century, but in the at the second half of the 19th century, the chemical science discovered how to make synthetic dyes. And a lot of chemical clusters arose alongside the River Rhine, and they distorted their water to the rivers and the canals. And there was a lot of it because it was very damaging to forestry, for fishermen, for the fishery, for the agriculture. So the Reich Court of Germany in 1897, they ruled that the water of a public as well as private river is the natural drainage channel, not only for the water that naturally flows from the bottom into the river, but also for the water often mixed with foreign substances, which has been used for economic purposes and has to be disposed of artificially. Well, this is a very generous interpretation of access to public waterways. So the access to public roads has a long history, of course, in the days of horse and carriage. For example, in cities, horses need to wear a bag to get the faces of their to get the faces, because otherwise the smell in the city was very bad. So that also was a rule that was set on the access of public roads. Nowadays, there is an increasing need for better and more dynamic matching of vehicle and road on each other. For example, because of climate change and emission reduction, you see that in many cities, zero emission zones, there are plans for that to realize them. Also, aging infrastructure needs a better of vehicle and road. So there are a lot of reasons why we should go from static to a more dynamic matching of vehicle and road. And the data for this is available, not always compatible, but in an increasing way it is compatible. You have the enterprise resource process systems, you have the transportation management systems and the fleet management systems, and it's all about data. It is believed that, conceived that companies don't want to share data, but I think in a not too distant future, a situation will rise in business where you will price yourself out of the market if you don't share data. Because if you want to receive reliable delivery times with the increasing amount of traffic and the increasing number of restrictions on access to the road, you need to share data to get a more optimized system for all. So you see a lot of digitization processes in business, but also on the side of traffic management. You see that on the left side. So now the question is how we could bring them together. What could we do as road authorities that they can't, and vice versa? And the point is that each company is very good in optimizing their processes for themselves, but what they can't do is influence other processes of other companies or other road users, for example. So now we'll go through some examples of intelligent access. The first country in the world where intelligent access has been in operation is Australia. And they did it because they want to have road trains, longer and heavier vehicles on the road. And they want to match that more properly with the infrastructure, and also to take away some fear from road authorities of what those vehicles could do. The unique point of the organization of intelligent access in Australia is that they put a trusted third party in the middle, so that the companies do not directly share data with the authorities, but on an aggregated level. And that's been a model for many other countries that are thinking about implementing an intelligent access system. This is a more basic system of intelligent access that is in operation in Italy. The use case is abnormal loads, and they use the opportunity to implement intelligent access because they digitized the process of getting exemptions for abnormal loads. And within the rules, there is the obligation of a transport company when the ride of the transport of abnormal load starts, you need to make a notification to the authorities. And because the process was digitized, also the transport companies needed another means to give this notification. And therefore they developed an application on the smartphone, and transport companies nowadays need to use this app to announce that their transport is going to start. So there was a legal base, and when they start driving, their location and their position and their weight are monitored. So the main actor is ANAS, that's the largest road authority in Italy, and they can monitor all the abnormal loads transport that are in real time on the roads. Another example of where there is a lot of opportunity to implement intelligent access is Austria. 13 traffic control areas are realized in the past 2 years. They are used at random, so you never know where there is a control team. That's at one of the 13 traffic control areas, and every truck needs to pass. It's a joint control by different authorities. Here you see that it will cost a lot of manpower and also maintenance costs to keep this system, physical system, alive. So there's a lot of opportunity for less manpower required, a huge cost reduction for roadside systems when you implement intelligent access. And there's also an incentive for transport companies to participate in such a system because they will not have that often time loss, and they will have a level playing field. In the Netherlands, we started in September with a pilot on a real-time pilot of intelligent access. In the pilot, 2 consortia are there consisting of 1 or more service providers. There are different types of service providers, but within our pilot, we have one that is more specialized in ERP. They are specialized in the ECMR, and others are more in navigation and map making, and others are more into transportation management systems. And there's in both consortia there is at least 1 transport company with an EMS1 vehicle. They will process 6 months of data to provide insight in the delivered performances by means of monthly reports on an aggregated level. And only with serious violations of the rules, there is going immediate notification to authorities. And probably this will have to be simulated because you can imagine that the transport companies will have very good behavior within the pilots. Results are expected in December 2022, In this case, the use case is EMS 1. Is a coalition of the willing. There is no, it's just that the involved stakeholders see that this will be the future of road freight transport, and therefore they are willing to participate. What uses cloud computing, so it is privacy by design, but I will come to that later. The legal base is sometimes there, but sometimes not. And in that case, we need to arrange things in the data collection agreement. And well, I leave it for this by now, for now. So privacy by design in the pilot phase. In a legal sense, there is no pilot phase within privacy legislation, because as soon as you are going to or are planning to share data, a data protection impact analysis is necessary. It's immediately required. So you can't say we don't do this for real. It's just a pilot, and after that we can go through that process of data protection, DPIA. It doesn't exist in a legal sense. There's also in the pilot phase no trusted party, third party yet. So you need to do it to build in that trust in the design of your pilot, and that's very hard to do. In the Dutch pilot, you see on the left side which type of data we want to collect and share. We ask a lot, and we will see where we end. But to prevent that, you stick, that the pilot stops in the beginning because you encounter the privacy legislation. You can start with data that cannot be traced directly or indirectly to a person, for example. And you can start with a connection with one of the authorities where there is the least resistance. Or you can choose to start with the data where there is already a legal base. In any way, there is creativity is needed. You need to look for opportunities, the introduction of a new vehicle type, for example, with high capacity transport. When zero emission zones are created in cities, that's a moment where you can introduce internet access as part of an exemption of permit system. The benefits for the transport sector, you need to search for them, because that will convince them, the transport sector, that there is also something in it for them. A level playing field. There's one of the companies that is of the consortia that is in our pilot. They want to participate because there is no level playing field. And they see that they want to comply with the rules, but they see that other companies that are overloading their trucks, getting the consignments, and they are losing customers because of that. Another company wants to create transparency to the customer about emissions caused during transport. Also, you can think of less control or expanding the range of services. But important is that intelligent access shouldn't be seen as a pure enforcement system. It's much more about cooperation between authorities and companies in order to contribute to social, but also logistical issues. Another important thing that you should think of, and that is often underestimated, is the follow-up on urgent notifications. Because you will define a threshold, and if companies are more overloaded than, say, 25% of what is allowed, then an urgent notification goes to the police. But is the police able to give a follow-up to each urgent notification? You also can use it for pre-selection, but also then, what if the number of deviations is too large to handle? So these are issues you need to think about. And what would be the logical next steps? Because you have now in intelligent access a vehicle to infrastructure communication, but you can also have a system in which you give information and data to the transport, to the vehicle. And one step further, you can create time slots within that. For transport companies, it's more likely that they will have a smoothly journey, and that they will get reliable delivery times. And maybe all this is in the far future, the necessary steps to be taken to realize automated trucks on the roads. But we're not so far yet. So I'd like to thank you for your attention, and I'm open to all questions you want to ask.
Thank you, Luz. I have one question. What do you think is the biggest barrier against this? If you have a short answer, because we need to have a break after that, against intelligent access.
Well, I think it's privacy. It's
Yes.
really, yeah. And you can only learn by doing, and you don't know what you meet in the process of the pilot.
No. Thank you again. Now it's time for a short break, so we will be back here at 11, and I think there is still some coffee outside if you wish. But please be back at 11 so we can start again. Hello again. So now it's time to start after a short break. And please also, you can follow this on LinkedIn, and please like some posts that will be presented on LinkedIn. And also, you who are online, maybe it will not be so much time for questions, but at least sometimes, and also for if you want to have answers afterwards. So can you please send them, write them in the chat you have. And here in the room, you can just tell me or Lisa afterwards. And also, if you have time, we will try to answer them during this, after the presentations has been done. But now, I give Rick Smits, also from the Dutch ministry, this chance to talk about the EMS2 test that they have done there and what they are planning. Yeah. So please, Rick, I will wait just to see that it works with the presentation.
You see my screen, Thomas?
Yeah, perfect. So please continue.
All right. Very good morning, everyone, physically in Sweden and online. My name is Rick Smits. I'm gonna talk you through the approval process of the EMS2 in the Netherlands. I give you a quick recap of the last 2 years and the coming steps that we are going to take in this process. I'm speaking on behalf of Rijkswaterstaat. That's the Dutch National Road Authority. I'm a direct colleague of Loes, who spoke to you about intelligent access. So we are a governmental organization and part of the Ministry of Infrastructure and Water Management. Quick something about myself. I'm an advisor of freight transport, and I'm working at Rijkswaterstaat for almost 2 years now. Did a master in civil engineering, and the projects that I'm working on right now are the approval process, where I'm going to talk about some data projects on container data and core network logistics. That's a program that we developed in the Netherlands to fit the right vehicle on the right infrastructure. To start, Loes already told you about Helsinki in the beginning of 2020. That was a symposium that included super eco-combis, so the EMS2. At that time, I was not working at Rijkswaterstaat. I was accepted to work there, but I started on March, so I missed this one. Too bad. But there were already some general conclusions on benefits and challenges within the approval of these types of vehicles. I think you all had a lot of experience in that conference. And after that, or right before this meeting, the team for the EMS2 approval was started in the Netherlands. So we have a few organizations that are involved, which is the ministry itself, including Rijkswaterstaat. We have the RDW, that's a Dutch type approval authority. So if you have a new type of car, a new type of bicycle, everything will be approved by the RDW, or not, of course. Then we have TLN. That's a branch organization for the transport sector. We have TNO. That's a Dutch scientific research organization, and of course a transport company who was willing to spend some hours in the project team to generate the first steps within the approval process. And something that's interesting within these type of processes in the Netherlands is that the transport company is the one who is paying for everything. And because this was way too expensive for one transport company, we started together with TLN and TNO a group of all transport companies that were willing to pay for the approval process. So we had I think 20 companies who were investing in this process for research and for basic approval steps within the RDW. Because interesting enough, the RDW was not in the approval team. We had the involved parties that I just told you about, but when the approval team was combined, the RDW did not want to be part of that group because they thought that they assumed their role to be the role of the one who says if the approval is accepted or not. You understand what I say. And along with the RDW, we have some organizations. One is the SWOF, that is doing desk research on what kind of risks to expect with these types of vehicles. So we have the parties involved in here, and we have the approval party, the RDW, that in the end will say if the vehicle is safe or not. The whole process is also a bit frustrated because of that, because the RDW approves vehicle types, as I mentioned before. And I think 3 or 4 years ago, we had a terrible accident. You see the picture on the left here with the children in this bicycle kind of vehicle. And there was a terrible accident with 6 children in this vehicle that got under a train because the vehicle, the brakes were off and didn't work anymore. And the RDW had approved this vehicle a year before the accident. So the RDW is, and so 3 children died in this accident. And you can imagine that there's a lot of political pressure on the RDW right now because of the approval of a vehicle like this. So also an approval process for the EMS2, like we are doing, is very frustrated by this accident that happened like 4 or 5 years ago now. On the other end, we have the cost for infrastructure. You see a little graph here. We have a lot of infrastructure, and I mean by infrastructure, bridges, tunnels, other types of structures in the road that were built between the 60s and the 80s, and that are now considered at the end of their lifetime and need to be replaced. So we have a lot of costs for infrastructure at the moment. So the minister, she's very worried that allowing these types of vehicles will cause more effects on the state of the infrastructure, and therefore will rise the costs for infrastructure. So these two political influences on the process make that it's not going as well as we want it to go. But I will give a quick big background on what types of vehicles are now allowed in the Netherlands. So we have already the EMS1. You see on the top picture. So the 25-meter vehicle of 60 tons. Regular freight traffic can weigh up to 50 tons. So we have already infrastructure that is designed for higher loads, because in other places in Europe, the maximum of regular transport is 40 tons or 44. But we are allowed to go a bit further in the maximum weight of these vehicles. So with all that political, all of those political issues, the RDW wanted us to do a lot of work. So they want us to make a risk analysis. And this is the most frustrating part of the last 2 years, I think. At point B in the top picture, you see the port of Rotterdam. So the main harbor that we have in the Netherlands. And we go up to Venlo. And Venlo is near the German border. And this is a commonly used road for container transport on the road. And this is the corridor that we wanted to use to do a test with this vehicle. But the RDW, yeah, they were very critical, and they wanted to have all the risk pointed out in a document. So we analyzed over 300 risks, and you can see that in on-ramps, off-ramps of the highway, underlying road network. We have a lot of roundabouts and a lot of... Sorry, Jonas, do you have a question?
Där då kanske, nu är det Jonas. Hallå, hallå.
Jonah? All right. So we had to do a lot of work with 300 types of risks and all different sorts of research on the amount of roads that that the vehicle needs to drive on in terms of roundabouts or regular crossroads. And yeah, that took way much more money and way much more time than we initially thought it would take. But the RDW, yeah, they really wanted to have all risks pointed out before they would give it a go to drive. Another thing that the RDW did was a performance test based on the dynamic characteristics of the vehicle. So we have some of the roundabouts or the junctions in the route from Rotterdam to Venlo, and all those special movements that the vehicle has to do. They checked on a test run with the little pines that you see here, and yeah, that's where the whole approval process has come to a stop, because the vehicle could not do the curves in the right way that the RDW wanted it to go. Also, there was a lot of length needed to get to a speed of 75 kilometers per hour, and those two issues, made that the RDW said we don't want this vehicle on the road. And yeah, together with a report from the SWOF that I just mentioned that was working together with the RDW, it came on hold, and we couldn't go further this summer. But we had another trick in our sleeves, an infrastructure test, because the tests that we did until now were based on one route, but we still want this vehicle to be fairly treated in an approval process. So we are still going strong, and we did last month an infrastructure test on two bridges, a steel one and a concrete one. You see the steel one below and the concrete one above, to do an impact comparison with regular traffic. Therefore, we used the EMS2 you see on the right picture, and we also used a special vehicle that you see on the left that has a perfect axle weight of 10 tons. And with that vehicle, we drove over the two bridges to measure the impact, and then you have a perfect impact of this 10-ton axle. And you also have the axles of the EMS2 that were weighed. You see that here on the picture. And you see here the impact that was generated on one of the sensors in the bridge. And that was compared with the regular traffic that is going over the bridge for the last half year. And with these measurements, we try to cover the infrastructural part of the political issues that I mentioned earlier. So for the traffic safety, we are still try to find ways to mitigate those problems that the RDW mentioned, because it's not that it's that those problems are not there. It's just that they made it very difficult to pass a test on traffic safety, because they were so fixed on analyzing all different risks, and that makes it very difficult to pass that test. But for the minister, she sees, of course, that a vehicle like this is very interesting. If you look at drivers' issues, that you have a shortage on that, and also economic value that you can generate with these types of vehicles. So we are now just focusing on this infrastructure test, and then next year again we will try to do again a test on traffic safety. So yeah, for the coming steps, we are generating results of this infrastructure test, and we will try to not do a road-based approach, but based on road characteristics. So we are now developing a program in which we can figure out where the EMS2 can drive or not. So not based on one specific route, but we just going to analyze digitally which on-ramps and off-ramps can be used by the EMS2 and which one cannot be used. And then try to figure out where in the network this vehicle can be operational used. Also, another thing is that the RDW is now, after this test, willing to cooperate within the approval team, and that's also a big step. Because that was a big frustration for the last 2 years. And now they're back on board with us to try to develop a way to measure the Super Eco Combi in the right way, and also to value the risks, and to think about solutions to mitigate those risks. To have some quick conclusions on this process for the last 2 years. Innovations are pretty difficult to implement, especially if you look at this political difficulties. But what also is difficult is that new solutions are also put into existing approval processes, and then you already have thresholds and boundaries for what the vehicle should meet up to in performance. And that's very difficult because this is a new type of vehicle. And you need that approval party, the RDW in this case, to be on board. And if they're not, it's impossible to go through such a process. And what I'm wondering is this something that you've also encountered in the countries that you are? I'm not sure if you're all from Sweden, but I'm just curious if this is a familiar story to you. That's the question that I'd like to end with in my presentation.
Thank you, Rick. And maybe I can make a short answer from Sweden, and maybe Per Ekström at the end of the day can make it longer, because this has been a very big question also in Sweden, this type approval process and approval process overall. So I think we can have a whole meeting about that, Rick, later, because it is a big issue. Now, in the agenda, it was a mistake from me, so it should have been 20 minutes for Rick. So we are on time, not 5 minutes late as it is, as you maybe think. So it was I who did a mistake. But now we will hear what is happening in the 4 different Nordic countries. So first we will have Finland and Vesa Minister. So please, Vesa.
Okay, now it's better. Okay, good morning everybody. My name is Vesa Männistö. I come from the Finnish Transport Infrastructure Agency. It is Trafikledsverket for Svenska. We take care of roads, railways and waterways in Finland. I'm briefly telling what is the situation of HCT in Finland. And these are the 4 topics I'm talking about today. History of what has happened, what are the latest experiences, and then some words of a research program of the winter premium, and then our plans for the future. And about the history. Well, we started about 10 years ago, and we raised the masses from 60 to 76 tons, and the maximum height from 4.2 to 4.4 meters in October 2013. And the reason for that was mainly to increase the competitiveness of our industry and reduce transport costs. And that change was very quickly adapted by industries, and we can say that this 76 tons has been a business as usual for many years already. Then, at the same time, the Finnish Transport and Communications Agency, they granted permits for piloting different types of HCT, both long and heavy, and that it was the plan to look forward at what will happen for the length of the combination and maybe for the maximum weight of the combinations. And those trials have been running for 8 years now, and more or less they have fulfilled the function of piloting, and only few of them are being started just now. Industries, they want to have something more than pilots. They want to get more permanent permits for certain stretches for transporting with heavier combinations. But that's a bit tricky thing in Finland, because if we give one permit, then we have to give another permit, etc. So it is a very, very sensitive issue. But the trials, they fulfill their purpose, and we could go for the longer vehicle combinations in early 2019. Of course, based on the experiences of the pilots and the needs from the industries, and we went up to 34.5 meters in beginning of 2019, and it applies to the entire road, street and private road networks. So in that way, we wanted to avoid, for example, the last mile problem. So everywhere where it is applicable to use these long vehicle combinations or long vehicles, they can be used. Of course, we as a road administration or cities or private road owners, they can restrict the use of longer or heavier vehicles, but it is case by case. These longer vehicles, they are also becoming business as usual very quickly. Volumes are increasing steadily. I can come back to that later, but they increase very steadily week by week. Then the latest experiences of what has happened, or what we have seen of these 8 years experience. First of the long vehicle combinations again, and they are very much used for a regular long distance transport. For example, transporting parcel goods or mail from Helsingfors to Uleåpori, or or other cities, we are long away from each other, and food products to supermarkets from the wholesale houses. Container traffic harbors, we can take 2 long sea containers at one time. So it is from the factories to harbors and vice versa. Wood chips, blankboard, cardboard, those are the users of long vehicle combinations. And as my colleague Otto always says, that every week somebody comes with a new idea that, okay, we can transport these with this kind of combination. So it is developing very quick. Where these long combinations, where they travel in Finland, we have some hundreds of traffic monitoring points along our main road network, and we have built up a system which detects, when, for example, longer than 28-meter combinations, and then we can plot those on map and make time series. And as you see the circles in the map, they are like from Helsinki to northern Finland to Oulu. So our main road number 4 is running between these cities, and there are really plenty of long combination traffic, especially in the southern part of the country. But we have this kind of system where we can monitor it easily where these come, and then make time series and analysis of the development of traffic. Then this time I collected experiences from 3 experts from 3 different organizations. And first of all, from Ms. Anu Cruz, she is the head of customer relations in our organization. We have meetings with bigger companies like industry and hauling companies every year, or with some even twice a year. And we collect their experience and their wishes, what they want from, for example, HCT. And Anu's comments from the customers, they are these 4, that our current traffic system serves very well, she says rather well, but I think very well, the long distance transport on the main road network. We have problematic crossings, roundabouts, but they are only few. There are some tens over the country, so they are not. It's not a big problem, but the need to provide suitable parking places for longer combinations, it is very difficult, especially close to Helsinki area. HCT, long and heavy, be it one or both, they kill 2 birds with 1 stone. Costs and emissions decrease hand in hand. So that is experience from the industries. And especially these long vehicle combinations brought big benefits to parcel goods transportation. But higher masses, beyond 76 tons, they are needed to reclaim the full benefits of the length. For example, in container transport, then you can get to a bit heavier containers at one time. And then comments from Otto, he can then add that his experience, I think he is the master of HCT in Finland anyway, so these are the best experiences. So we had very tight technical requirements for the combinations, and we chose to implement these to wide network. They seem to be right decisions. And in long distance transport, the long combinations are taking the field very quickly. But it's not only the long distance story. There is plenty of heavy and long vehicle combination transportation between factories and harbors, some tens of kilometers. Accidents can't be avoided, but it's not HCT which is a reason. They happen, be it a bigger or smaller combination. And then the productivity of drivers is in many cases even 30% higher than in EU, and emissions can be more than 25% lower. And the third experience from the forest industry from Pirjo Venäläinen, and her comments were that the HCT is decreasing fuel consumption per transportation unit, and it brings necessary savings for the forest industry. And also piloting of HCT, it has activated road and bridge stress research in several countries and also cooperation in research. And finally, HCT is not competing against forest product railway transport, but it complements it. Forest companies say that, okay, we take the woods from the forest with HCT to a railway loading terminal and then continue with the railway. So they are not competing. They always use railway when it is possible. And then of the research winter premium, University of Oulu, they have a research program how to utilize the frozen road structures in heavy transport. And it's shown in this picture that when the road is frozen, part of the year, then it would be possible to utilize higher masses during that time. But there are, as you see, there are 4 very interesting research questions that how it can be implemented if it would be allowed on our network. And finally, for the future, higher maximum weights. I think the length is now 34.5 meters is about the maximum. But there is a demand for higher maximum weight. What it would be, 84, 90, or even more, that's to be investigated. It's more complicated issue than the other dimensions, and absolutely cannot be allied to the entire road network. But that's what we have discussed with the industries, that they understand that it is something, some thousands of kilometers if it materializes someday. We haven't got any political decision for that so far. We also have a new long-term transport plan. It was not included in that. But our ministry has asked us to do some more investigations, especially to find out the bottlenecks what we have on our current dimensions, on our road network and street networks. And also we have 400 restricted bridges, and how many of those are really critical. I have been doing that work for some time, and it seems to be that 20–30% of those are critical for heavy transport. That's all by now today. Thank you.
Thank you, Mr. I think we have time for one question. Is it someone in the audience? Otherwise, I will ask you one.
Okay.
What do you think is the most important thing you can say to other countries who wish to implement longer weeks? I know, like Netherlands are doing tests, and maybe they plan to do it in Denmark and also other countries. So,
I think,
if you say just one thing.
well, we have done it for some years in Finland already. So my advice is that you just go forward with it, because we have done so much work, we have so much experiences already. So the countries are not that different. So that's my proposal, that just start it and do it. But then you need very much cooperation between different parties, like in Finland, us and the communications agency, ministry, industries, hauliers, Volvo, Scania, everything. So that's very essential. Because in many places you need help from different companies, different agencies. You don't do it alone.
Oh, thank you. And thank you again, Vesa. Here you can also have a Vesa, please, you can have a book for reading on your way back about the history here at Lindholmen. Yeah, and now, Martin, we will continue with Denmark. So please come here so we will hear what you have to say from the Danish side. But you move. No.
Testing. Thank you. Well, yeah, tack. Well, hi everybody here in the room and in all in the web. Well, I'm going to tell you a little bit about analysis we made in Denmark regarding the DO2, as we call it. Well, it's just an overview of this presentation. We made this analysis. We are doing this analysis in a cooperation between the Road Directorate and the Danish Road Safety Agency, which, like the RDW, has the vehicle approval. Maybe. Yeah, exactly. Well, the background of this analysis that we are doing is that there was a political agreement for about a year ago that we should do this analysis, and we have this year to be finished. So it's just about to be finished before Christmas. And the analysis includes these dots. We must analyze the road space for these trucks, as you all know, and the impact on traffic safety, and the demands for the vehicles, of course, and what are the consequences, economical and for society and business, of course. And of course, in this time, we need to have focus on the CO2 emissions as well. And finally, we must come to a proposal of possible road net in Denmark. Next slide. Yeah. Well, in order to do this analysis, we started out to say, well, what's going on in other European countries regarding the DO2 trailer or EMS2 or whatever we call it. So we need to have a basic knowledge, and for doing that, we asked Sweco to do an analysis, a study of how this works in different countries. And the analysis, well, the frame for this task that we asked Sweco to do was to look into longer road trains, 32 to 34 meters, including advantages and disadvantages in some areas, but the focus must be on the DO2, which meaning the A double, as you all know. So Sweco started out with this study, and we asked them to have focus on legislation due to the EU Direct and 9653, as you all know. And focus also on the vehicles, the turning radius, and also the rules regarding security and standards. And also, of course, from my point of view, the infrastructure, the traffic safety, and adjustment of the crossings and constructions, as we all heard Rick before in Holland. So Sweco started out with a desktop study, literature study from the web, of course, as we all do it, questionnaires, interviews, and we all looked into European countries and find out, Finland, Sweden, Holland, Spain is doing some kind of tests with the DO trailer. And we also included Germany because they have made, they're a little special because they, as you might know, they have legalized the EMS1, but they are very, they're not moving so much forward. So they have a lot of knowledge that we thought we could use in this. Well, it's the same type of knowledge that we should use regarding the DO2. Well, the legislation, we have the 9653, and there's Article 4, and we have a possibilities for the DO2 in either part 4 or part 5 in this article. There might be a slight mistake in this overview, but I have a slide on this later. And we asked in the European, in the EU regarding this, because if you need to go with the EMS2, you have to notify the EU. So we asked them if there has been any notification, and they came back. Some countries did it, but they couldn't find all the details. So it was a little special because of the respondents, but that's what we collected. So the vehicles that we were discussing, of course, is an overview, and it's assumed that the type approval vehicles are used as below. You see here, and of course dimensions, the turning ratio, the demand for brakes and traction, and the acceleration, of course, as Rick also stated. And Sweco also found out about the most common additional demands for the vehicles, set on the screen here. They are not the same everywhere, but EBS, ESC, lane assistant is normally used. So an overview of these countries. In Denmark, of course, we still have the trial with the EMS1. And Holland is they think of 72 tons, and Spain 70 tons, as we know. So that's an overview of the vehicles that Sweco find out. So the infrastructure, of course, focus on the bridges, geometry, the road space, and traffic safety. How's the capacity, weight for these trucks? We made a test on a field with help from a haulier who could combine the EMS truck to the Duo 2. So we made some tests regarding road space. Of course, traffic safety. Sweco found out that the traffic safety is equivalent as for ordinary trucks and road trains. It's very important that we keep the different traffic users divided and focus on known challenges. General exemption is the right turn, of course. Focus on the mirrors from the driver. The assessment that was from this study was that based on the data, there are no impaired based problems based on that if the routes are suitable for the heavy vehicles, and if the number of vehicles are reduced, they might not be an issue with this. But as the longer EMS and EMS2 primarily only uses the secure roads with very few vulnerable road users, there are little empirical data on accidents. So we think there must be a very cautious approach for this. So to sum up, this literature study that Sweco made for us, Duo 2 is legal in Finland, and in Spain, Sweden as pilot projects, and in Holland they are not moving so much further at this moment, but they are coming onto it. The vehicle demands based on the 9653 and infrastructure, we need some adjustments, and for the traffic safety, of course, cautious approach, we think. And the environmental gain is very nice, very possible, but what Sweco found out that it's the same source is used almost everywhere. And the source is, of course, from Lena and from Lena, the DO2 measurement that you made for the project. So that one is very well used everywhere in the study and literature. So, well, that was just the introduction of the study, of the analysis. Yes, thank you.
Yes, unmute myself. Thank you, Martin. And also a question for you. Do you think it will be possible, or when do you think it will be possible to drive these vehicles between Denmark and Sweden?
Well, first it's an analysis that we're doing, and it isn't even been decided on a political level yet. So, but if it will be decided, then we have to discuss it with the Swedish authorities, of course, and also with the Öresund Bridge, because they are a third road authority. So we have to discuss it both with the Öresund Bridge and with you guys in Sweden, of course, before we do it. But first of all, we need a trial in Denmark, and then we'll look into that.
Thank you. And I think it's interesting that you're going in the same direction as we. So thank you again. And you will also have the possibility to read a little bit more about Lindholmen Science Park.
Thank you.
And now it's time for Norway and Elin Nordby. So I hope she is with us. Yeah, now I can see you, Elin. So please try to show your slides.
Using it?
Yes, but not in presentation mode.
I'll start by saying, as I do every year when we're talking about HCT and the status in Norway, that in Norway the focus has been and primarily has been and continues to be on not the extra long and extra heavy vehicles, but to be able to have 60 tons and 25.25 on as much of our roads as possible. And we'll be giving you an update today on a couple of developments in this field that are trying to do just that. Starting with, this was an initiative that I talked about last year as well. As you can see from the numbers there, the EMS, the 25.25, used to have about 5,500 kilometers of road network available to them, whereas the 24-meter timber transport would have 55,000, meaning that there's been some push from the industry for quite some time. Why can't the EMS go on all the same roads? Yeah.
You haven't changed slide for us. We still see the first slide.
Okay, this is.
I think you need to turn off the presentation mode for yourself and change slides.
Okay, I can do that.
Mode as we see. Yeah, now we see the second. So please have it in this.
Yeah, okay,
yes,
that's fine.
Continue to change in that.
Yeah, that's fine.
Yeah, thank you.
Either way, recapping, the EMS have about 5,500 kilometers available to them, whereas the 24-meter timber transports have 55,000 kilometers available to them. And there has understandably been quite a bit of pressure from the transport industry, since why can't the EMS go on the same road network? So back in 2019, we started seeing if this might be possible, not for all of the EMS combinations, but the types 1 and 2, and also the 24-meter combination, which is sometimes called either the Swedish combination or the type 4 EMS. And provided that they are able to fulfill the same tracking requirements as the timber transports, they should, at least in theory, be able to travel on the same roads. So we had a consultation about changing our regulations on this, which ran from March to May last year. But the responses were quite varied, I guess I could say. The transport industry were very, very positive. Their only concern was how quickly could they have this, and with the minimum number of restrictions, basically. Whereas the road owners or the road authorities, the counties and the municipalities, they were quite skeptical, I think it's fair to say. So much so, in fact, that we had to rethink how we were going to do this, and we ended up not changing our legislation to have this permitted on all of the same roads, but rather to establish a new category where the road authorities can decide if the EMS can go on the same roads as the 24-meter timber transports. And we did this by adding another column in our quite infamous road lists that states whether the EMS is allowed or not. And for the national roads, pretty much all of them are now open to the EMS. There are a couple of mountain passes that are closed, and also a bit of the E6 up north, which just isn't suitable, especially with the winter conditions they're having. County roads, they're now up to about 20% from, I think, 10 to 15-ish before. And the municipality roads, the numbers are still quite low, but it's an ongoing process that with every new circle of road lists, more roads are being opened. So it will be very, very interesting to see where we are in a couple of years. So that's one of the initiatives. The other is something new from last year, which is that Norway, on the one hand, has quite a lot of 60-ton roads now. We also have a lot of roads that are only there where the axle loads are limited to 8 tons, and especially the category called the T8 or the heavy 8, which are roads with low bearing capacity but with fairly okay bridges. And this has been, especially for the forestry industry, quite a headache because they're not. It's just not efficient to transport timber on a 24-meter vehicle with 8-ton axle loads if you're limited to 50 tons. So they have, I suppose, made a proposal last year to see whether it would be possible to increase the permitted total weights on 8-ton axle loads to 60 tons, permitted that the vehicle combinations have enough axles. And then the Directorate of Public Roads and the Public Roads Administration in general evaluated this proposal and came to the conclusion that this might actually be quite a good idea. So we had hoped to have a public consultation about this published the 1st of December, but there was a bit of, I suppose, bureaucratic lag in the process. So we're now hoping to have it out before Christmas, and then for the consultation to run to sometime in March. And as with the EMS on the timber road, road network, it will be up to the road owners to decide if the roads will be open or not. So we're also quite interested to see if any roads will be open at all, and if they are open, how much, and if this will produce a coherent road network or if it will just be stumps of road here and there. We're excited to see, or anxious to see, I suppose. And the earliest expected entry into force will be November 22, due to this, again, the cycles of the road lists. So the proposal doesn't just cover 60 tons on 9 axles. It also has proposes increased weights for the 8 axle combinations, and also a couple of tons for the 7 axle combination. As with the 60 tons on the 10-ton axle load roads, you will still need 19 meters from the first to the last axle. The additional requirements will be that the motor vehicles will have 2 driving axles. This is new. I mean, for the timber transport, this is pretty much standard anyway, but it's never been a requirement. This will now be a requirement, both for the timber transports and proposed also for the 24-meter combinations. The other requirement will be, in order to make sure that the roads don't get completely destroyed, the trailers will be required to have twin mountain tires on all axles. And so just now, because we have opened the 24-meter road network for EMS, or at least the regulations allow for it, these new regulations will also encompass not only the timber transports, but also 24-meter combinations and EMS types 1 and 2, if they are allowed to drive on these roads. Just a couple of other developments. The 74-ton timber transport trial is now finally live. I will be giving you a much more detailed update on that a little bit later. And we are also looking at what might be the next logical steps, which is given that Norway has a lot of roads that are just never going to be open for 24 or 25.25 meters. Is it possible to do something to increase the efficiency of timber transports and other transports on those roads? Could the total weight maybe be increased from 50 to say 54 tons on certain provisions, or is it possible to do something? So that's what we're looking at. We expect that we will be looking into in 2022. Thank you.
You will talk more later about your 74-ton pilots, but I have a question. What do you think about longer vehicles? I know because you have very narrow roads and winding roads, it's not so many places where maybe it's any use of it, but is there any ideas about longer vehicles in Norway? So maybe it's the same question as I had to Martin before, if it will be any dual trailers going from Oslo to Copenhagen, do you think?
I mean, we are certainly talking about it, but so far it's been difficult to really get a firm decision on whether or not this is something that we're going to proceed with or not. And that's, but I mean, given that Denmark is now also looking into it, I suppose it's just a matter of time before we will have to start looking into it officially as well.
Thanks. I think there is time for more questions. Is it any questions to Elin? Otherwise, maybe we can take it after Kenneth also had talked, and then we can have questions if there is any time to all four speakers from Nordic countries. So please, Kenneth Atanason from Trafikverket, the Swedish Road Administration. Now we will hear more about what is happening in Sweden. Are you there, Kenneth?
Yes, I'm here. I'm trying to start my video here. And I think I managed.
We see you.
So
please proceed.
But you don't see my screen.
We do.
You do?
We see it. We can
okay.
See it.
Okay, perfect.
Continue.
Okay, thank you. My name is Kenneth Natanason. But do you see my presentation?
Yes, we can see it.
Okay.
So we see max tillåten bruttovikt. You just changed, and now we change back.
Okay. Oh, good. Okay. I want before we start, you told us, Thomas, something about the development in Sweden, and we also have began the day with two presentations from two wise men. One was the professor in transport system, Jonas Eliasson, who actually told us about that actually the share of transport between the modes are relatively constant over time, independently of whether the fluctuations in the efficiency between the modes. So that's actually a very important feature that we have to have with us. And we also had a presentation from the wise man, should I say, political Gandalf in the area of transport efficiency, Anders Åkesson, who told us that actually we have to look at the whole transport chain and we have to be more efficient in each modes. That can sound it's a rather easy conclusion, but in the debate it's not so clear that that's the way we should see it. So I think it was very important things that come up here. And one conclusion from that is that we actually have to be more efficient, and that high capacity transport is a very efficient tool to both be more efficient and to reach the climate goals, especially in the short run. And in Sweden, we have actually, if you look at the development for heavier vehicles here in Sweden, that's you see the development from 1920 to 2000 here, and that's actually, I think I said that last year also, 0.8 ton each year that the allowance increases. So it's a natural development that probably will continue to increase. But the goal that we are looking at now in Sweden are 74 tons, and we call it BK 4. It's a loading class that we have in Sweden. And we open up the network for BK 4 in 2018. And at 2019, we actually had opened, actually at the end of 2019, we had opened 20% of the state roads for BK 4. And we also have a strategic network, that is a network of roads that are prioritized by both the industry and the transport administration. That is most important, and it's approximately 60% of the state roads. And for that road, we have 30% of the roads that are open for BK 4, and that's the one who is open is the one who is yellow or orange in the map to the right. And we presented an implementation plan in April 2020, and then we for the first 3 years, that is 20, 21, 22, we had a plan that we should open 52% of the strategic network and 33% of the state roads. And the plan for the next 3 years are the blue roads here. And for 2025, that is the next 3 years phase, we had a plan to open 40, respectively 60% of the roads. And I also want to mention that we have other road administrations in Sweden. We have both private roads and municipalities that are in charge of roads. But we also actually update this implementation plan each year. And now I think it was published in April or May or something like that. You have the link at this slide. That you can reach the implementation plan. But the status in the end of 2020 was over approximately 26% of the state roads and 40% of the strategic roads. So we actually outperform ourselves here. And we also have the new plan for 2023 here. We have the ambition to open over 40% of the state roads and until the end of 23, and 60% of the strategic roads at the end of 2023. And as you see, if you look at this map now, the yellow or orange are the ones who are open for BK 4 right now, actually, in the end of 21. And the blue ones are the ones that we plan to open. So we are actually, we have the plan to open now for 23. If you look at the goals here, 40-60 is actually the same that we for a year ago planned to open for 25. So we go forward in a faster way than we actually had thought that we should be able to do. And that's fantastic. But it depends on that we actually are able to open the roads that we think we don't have to do any activities to reinforce them, bridges or roads. So it will take a little bit longer time in the next phase. And before I go into longer, I want to say that in the national plan that we are working with now for BK4, we want to open, we have a goal to open 70 to 80% of the state road, of the strategic roads for BK4 at 2029. And then in the new plan, we have the same goal to 2029. It's unchanged, but we also want to increase and continue our process to open up all the former BK1 network to BK4. So we have the goal to 2033 to open 80 to 90% of our network for BK4. Regarding longer vehicles at the Swedish network, if we connect to the political situation, nothing has actually happened in Sweden, and Anders didn't have so much comments about that, and he knows the political playboard more than me. So I have nothing to say about the political situation, but as we have mentioned before, we can open 4,000 kilometers for longer vehicles within a year from a decision. That is, we have to make some planning and so on. And additionally, 500 kilometers at 2025 was the former prognosis, but I know that it has been some changes in the national plans that might affect this additional 500 kilometers. So because I think some mid-separation of roads has been prolonged in the further in the plan, so it might be some changes there. But the socioeconomic analysis is very clear. The benefits is around 1 to 1.4 billion euro, and the costs are less than 10 million euro. And it's that we have to correct some tight roundabouts and some road. We have to broaden some road widths in urban areas while passing them and so on, like Rick told us about earlier. So we hope it's a very, very beneficial way. And in the national plan, we actually stated also that this is an efficient way to make the industry more competitive and to reach our climate goals. So, thank you.
Thank you, Kenneth. I will start with a question to you, Kenneth, and maybe we will have more. I know that we are quite prepared for these longer weeks, but as we heard earlier, it will be problems with last mile access, and that we have also other road owners. How well prepared do you think municipalities are for introduction of longer vehicles to their terminals or harbors or things like that?
It's a very good question. We actually stated that in the report in 2019 that we probably have to look over that and probably need an assignment from the government to look into that and make the necessary analysis. And it's not you also have to think about a broader picture here if we get that as kind of assignment, because we also have, as Jonas was into, we have to think about how the electrification also within that aspect. So I think it's a broader picture than just longer vehicles, how we should use the logistic system, especially connected to major roads and the gränssnitt in English, the connection to the urban logistics system.
Thank you. Yeah, now I think we have still 5 or 6 minutes, so please, if you have any questions here in the room, and it can be not just to Kenneth, it can also be to Martin, Elin, or I will check also online if there is any. But please, now you have the possibility to ask questions to some of the people who knows most about this.
Okay.
Please don't hold in.
Okay. Okay. Lennart Sider here. I have a proposal for bridge formulas. Every country with self-respect have their own bridge formulas. Can it be that the transport agencies start cooperating to use the same bridge formulas? The Danish and Swedish bridge formulas are not the same as for dynamic amplification factor. And since we have a bridge together, this could be a very good starting point. So it's open for the transport agencies to cooperate.
I think in the ground, we have Eurocode for all bridges. That I know. Then I know that we are not any bridge experts here, but of course this is interesting in all ways because we don't have the same regulations for roads either. And I know so, but I think we are trying to get more and more as the other Nordic countries, so we should have the same or similar rules. Maybe not the same. That will take some time.
But I can. Sorry,
please.
I can add something there. Lennart has reached this question before, and I have spoken with our bridge experts, especially related to the Eurocodes, as you mentioned, Thomas, and they say that it doesn't differ so much actually. But Lennart maybe has another view on that, but our expert says that it doesn't differ so much.
No, I think it's actually that it is like that, but I think still it's an interesting question because it's good that we can have similar. Now I take some questions from the online people. So Elin, it's a question to you. Do you demand also double tires in Norway or only more axles?
It kind of depends on which vehicles we're talking about. And we don't think we have any specific requirements for this except for the 27-ton semi-trailers. Because so far, the regulations applying to the timber transport, it hasn't been necessary to make these requirements because they will have this equipment anyway. So there will be a change with the 60-ton combinations with 8-ton axle loads coming up now. Otherwise, as far as I can remember, at least, we don't have any specific requirements for twin-mounted tires in our regular regulations on permitted weights. No.
No. No, it was a question from Tavi, so maybe he can ask it directly to you also afterwards. And then you also have a question, maybe not so much a question, but in South Africa, they have a performance-based standard project, which is still in pilot form. How can we package these results to a fast-track policy shift in other countries outside of the Scandinavian region, and I'm not sure if it's so much a question for our group if it is outside the Scandinavian region, but I think it's interesting with these performance-based standards to look more on, actually not exactly the dimension, it's more important what damage they can do to the infrastructure or of safety, of course, too. So I think the idea with performance-based standards, it's a good idea, but is it someone else who wants to say something? Because I know, like in Finland, in some way, it's also performance-based standards that you have, but they should have some sort of stability. So I don't know if Otto or Vesa can add something about that. You want to say something, Otto? So maybe it's not so easy because it was not a direct question.
About performance-based standards, so the turning rule is performance-based standard. Truck length is performance-based standard only at the parking place. And when we talk about the stability, we have not added a stability rule to old combinations with 2 joints, only for the new type of combinations with 3 joints, so A double, AB double, or B triple. So we have quite a lot of research behind, and now it's a quite simple calculation model that can evaluate all trucks and what's the estimated stability based on coupling device placements and wheelbases.
Yeah, thank you, Otto. I think now it is 12:15, so we need to have lunch and also be able to speak to each other. I think that is also an important thing with this. So thank you for this, and we will be back in an hour, 1:15, and it's the same thing for you online. I hope you can be connected again 1:15. So thank you for this. So we will be back. Hello again, everyone, and I hope you are back also online. Now we will continue and hear more about an interesting project, but we also heard a little bit about last year. So it's about the Autofreight project. And we will have 2 speakers here, both Lena Larsson from Volvo and Sara Thiel from Borås Municipality. So please.
Börjar ni presentationen, eller? Ja, där. Så, Sara Thiel from Borås City and myself, Lena Larsson from Volvo Technology. We will guide you through this presentation around Autofreight, the experience and future challenges. And we will take this in Swedish. Autofreight-projekten började 2016 och Sara ska berätta, och då i början tittade vi på automatisering och självkörning och logistik. De senaste 2 åren så har vi hållit på med transport av gods, lärt oss en hel del om det. Framöver så kommer vi jobba ännu mer med logistiken och expansionen mot 34,5 meters vägnätet och även titta på distributed propulsion och driver support. Då ska vi se, nu ska vi klara detta. Vad är det då vi har lärt oss? Alltså det här är under den här tiden vi har kört försöket, och det är att vi har visat på C2-reduktionerna, vi har lyckats få ner transporterna. Vi har ett stort önskemål från kunderna, transportköparna var med. Systemet fungerar. Det fungerar att dela på kunskap, resultat och transportör. Och vi ser också en flexibilitet mellan kundernas företag, alltså i säsongsvariationer, så man kan ha nytta av samarbetet. Vad är våra challenges? Det är att alla vill ha sina lastade container klockan 6-7 på morgonen. och då, att de har hämtats tomma klockan 12. Ingen vill ha någon container på eftermiddagen. Så matchning av containers också. Vi har för få trailers med idag, så vi måste ha ett större flöde. Det är att hitta tidstjuvarna. Vi har sett tidstjuvar, men det gäller att hitta dem, definiera dem och kunna åtgärda dem. Hitta duktiga chaufförer, kunna göra backnings- och rangeringsövningar och sen att jobba såklart mot serieemissioner. Nu lämnar jag över till Sara.
Och bakgrunden till vårt samarbete, det är ju att Borås är Nordens ledande e-handelsnav. Vi har många av landets ledande e-handelsaktörer hos oss med extrema krav på logistiken. Det är logistiken som driver lönsamheten, det är logistiken som driver e-handeln. Och att då vara stad i den här kontexten, det ställer krav på oss. Företagen, e-handelsaktörerna, de kräver samverkan och proaktivitet. Och staden har valt att svara upp för att utveckla effektivare trafiksystem till och från Borås. Och det här är bakgrunden då. Och när vi började jobba med trafiksystem och logistikutveckling, då sökte samtidigt Volvo en testarena i närheten till Göteborg. Och man ville testa med verkliga flöden, verkliga volymer, ny teknik och HCT-lösningar. Så det var grunden till arbetet. Och redan efter att ha kört 1 år så kunde vi presentera förra året den här bilden på våra resultat. Vi såg hur vi minskade antalet transport på riksväg 40. Vi såg hur vi nådde transporteffektivitet. Men vi hade också ett resultat som vi arbetat upp då i Borås. Den här unika samverkansmodellen som vi kallar Borås Multi-Client System. Där LOs Frista arbetskläder och Carry Logistic gemensamt fyller transporterna till Viared i Borås. Med möjlighet också att koppla på export, i detta fall Volvo bussar, för att köra tillbaks till hamnen. Och detta med full transparens. Och vi har också fått bra resultat när vi tittar på miljöpåverkan. Vi har minskat bränsleförbrukningen med 34%. Det finns kapacitet och möjligheter att minska bränsleförbrukningen ytterligare med utvecklad logistik eller utvecklad teknik. Och vi ser i Borås att detta är ett framåtsyftande trafiksystem. HCT fungerar väldigt väl och det efterfrågas av våra företag. E-handelsaktörerna, de har krav på sig att minska sitt klimatavtryck och HCT dockar rakt in i deras miljöarbete. Så att med den volym som finns i Borås så har vi nu sagt att vi ska bli HCT City. Vi ska arbeta aktivt för att expandera HCT-arbetet. Vi kommer att utöka inom snar framtid, men också vi har verifierat volymerna och konsoliderat det. Och här ser ni nästa steg. Vi ska upp i 3 turer per dag.
Per fordon?
Både 3 fordon och vi ska upp i 3 turer per dag. Sätter vi det här trafiksystemet, det kräver en driveport och det kräver också lokala dragningar. Då kan de här 3 fordonen som vi ska upp i, som Lena säger, gå som skyttlar på 40.
Då går vi från 4 till 12 gånger, en jäkla massa trailers.
Ja, det är det. Så att, och det som är intressant då, det är ju att vi får effektiviteten, men vi kan också öka det geografiska upptagningsområdet.
Ja, vad har vi då gjort också? Vi har under den här tiden tidigare så har vi jobbat med, som vi säger, att titta på grunderna för automatisering och självkörande. Och där finns mycket kvar att göra, men jag ska säga att Chalmers har lärt sig mycket, Combitech har lärt sig mycket, vi själva har lärt oss mycket. Vi har fått ut ett antal doktorander, vi har en hiskelig massa sensorer på bilar och vi har kört mycket emellan här och mätt. Och vi har också kört mycket på AstraZeneca. Men vi känner att det här ligger rätt långt framme, så framöver här nu så vill vi fokusera på de low-hanging fruit vi har att få ordning på HCT-systemet och titta mer då på vad vi kan göra med att få in eldrivna enheter. En annan sak vi har lärt oss är att det här är ett axplock av de kombinationer som vi har kört. Alltså det går en hiskelig massa olika containers och de går en massa olika sorters variationer. Och för att kunna räkna bränsle så måste man veta vad man kör, för att det har minst lika stor betydelse hur containerna sitter och vilka container man kör. Så att det här är något som vi ska försöka få verklig ordning på nu, och det är våra tekniksprångare som jobbar med det. Då har vi gjort en liten sammanfattning här så ni ska förstå de här, jag har skrivit ner de här 35%. Då. Alltså att om man kör en 40-fots container så tar det en viss mängd bränsle. Kör man 2 20-fots container som man kör här, de måste sitta längst bak eftersom de bakåt lastas. Då är det inte mycket man vinner på det, men man vinner åtminstone betydligt mer än en 40-fot. Går man till 2 40-fotare vanliga så kanske man kommer ner 30%. Går man till high cube och sen 45-fotare så kanske bara genom att ta de här alltså containerstegen, om man tittar på det och att man tänker på hur man lastar. Sen så har vi allt det andra som vi ska titta på också. Ja, och så här ser nu ska vi se. Ja. Så här ser containerflödet ut i våran trafik nu sen i mars. Och då kan vi säga att vi kan bara lasta en 45-fotare. Som vi ser, 20-fotarna ligger hyfsat stabilt. I juli körde vi väldigt få transporter, så att det är inte att det var mycket mer 20-fotare där. Ni ser att de blåa är 40-fotare high cube. Det är våran bulk. 40-fotare vanliga är inte så, det är lite mer än 20-fotare. Men så i september så kom det en hel del refrigerator, och det kan ju vara att det var de som fanns lediga. Men vi ser att det kommer mer och mer 45-fotare, så vi vill utveckla så att vi kan ta dubbla 45-fotare, och då behöver vi lite längre dragstänger på dolly. Så det är också sånt man lär sig. Vi har sökt ett projekt för de kommande 2 åren hos Vinnova igår. Och då ska vi fortsätta med de här frågorna. Och då känner vi verkligen fokusera på det här att få upp containerflödet som vi sa. Ytterligare sänka energiförbrukningen, få fram nya tekniker. Och så att se liksom, hur skulle man kunna utnyttja en driven trailer. Och sen så titta, i hamnen måste vi komma åt också, och alltså få effektivitet både i viaredsområdet och i hamnen. Ja, nu är det du igen.
Ja, och det här i nästa steg då så är det ju väldigt intressant när vi ska implementera 34,5 meter. Hur ser det ut? Vad har vi för brytpunkter? Här ser vi till exempel att vi pratar om våra flaskhalsar. Vi kan inte köra igenom Borås till exempel. Och applicerar man den här modellen som vi jobbar fram så är det ju att titta på att hur kan vi få störst nytta helt enkelt på vägnätet.
Vi har ju ett rätt begränsat vägnät som kommer öppnas för längre fordon, och det är inte samma vägnät som är 74-tons vägnät, så att man får verkligen jobba, och där behöver vi jobba mer. Sen har vi hamnen. Här är på Ellos har byggt ett helt nytt logistikcentrum med HCT som input. Och ni ser, här klarar man gott och väl att backa in en hel kombination. Där står våran bil nere i änden, guldbilen. Och idag så rangerar man. Det går rätt hyfsat bra. Du ser också fotot där om man ska backa det här, det är inte så himla enkelt. I hamnen då, som vi har Göteborgs hamn, det här har vi ju de stora tidstjuvarna skulle jag säga. Vi har ett geofence som är det blåa, där står 2021, där vi mäter idag. Från det geofenset in till att man har hämtat sin container och kommer ut igen så tar det mellan en halvtimme och 1 timme. Det är väldigt mycket kö. Det är ännu mer kö, så vi ska flytta det geofenset längre ut, för kön går ända ut på gatan. Majoriteten av tiden är tagen i kö. Sen är det väldigt trångt inne. Det ser ni, där som man ska backa in i sina dockor. I Finland så har man helt lämnat det här med backning, utan man kör igenom i hamnarna, och det hoppas jag att vi hamnar på i Sverige också när vi väl implementerar 34,5. Så vi har jätteduktiga chaufförer som är stolta över sitt arbete. Jag hade tänkt att visa en film, men där kan ni få se, om ni tittar på den, vi kommer lägga upp den, kan ni se Håkan backa, och vi ska också be bilarna köra. Vi har också 2 långlink som går i ett annat försök som finns med i de filmerna som vi lägger upp. Och med detta så vill vi tacka alla våra partners, Vinnova, ja, och framförallt då Håkan och Zoltan som kör för oss och gör att vi kan ta fram de här resultaten.
Tack.
Ja, tackar. Ja, ni var snabba. I can take maybe the question in English. And I think it's interesting always to know what has been the most unexpected challenge in these projects so far, but you didn't think about before.
I think the most unexpected was the things with autonomous driving. And also from the beginning there was that there should be an idle that should transport goods locally in Borås by itself. So I think that when we started the project, the belief in new technology was far too high. So and then we learned so much doing this, and we learned a lot for safety system. We learned how hard it is to reverse, and maybe you don't have to reverse if you have goods where you can, like we say, we can change in the harbor so that you don't have to reverse. Why should you reverse when you can drive straight? You have to reverse in Ellos because you have to, or at every industry in Borås because you load from the back, so you have to back up and you have to separate the combination anyhow, so you don't need to reverse the whole combination because each trailer should be parked separately, so we shall not solve problems that you don't need to solve. We also need good driving capacity, so we will have more and more driven axles. When you have long vehicles, you need a lot of driven axles.
Yeah, thank you. And I think I must add one thing also, because I was the beginning in this, I know we had the meeting in 2014 or 15 about that it should be autonomous driving at Asta Zero, and everyone thought it should be no problem. But I think it's so, because in electrification, like Jonas Eliasson talked about, that is the opposite. It's gone much faster than we expected. But autonomous driving is really the opposite. I think we are now 6 or 7 years later, we think it will be much further away than it was then.
Yeah, and that's why we're moving to electrification.
Yeah, so I think it's a good idea. Yeah, but thank you. And here you also have something to read.
Thank you.
On the way back. Maybe not so long way for you, Lena, but a little bit longer for us. So thank you again.
Thank you.
And now we continue with the next, and now it's time for Elin Norby to come back and now to talk about the 74-ton timber transport trial, what we have planned in Norway. So please, Elin.
Thank you. I will do it in this format again. I think that's probably the safest.
Yeah. So please continue.
So hi again. Very happy to be able to update you a little bit on our 74-ton timber transport trial. We've been talking about this now since back in 2017 and or in 2018 when we first got the assignment from the ministry to have this trial. The objective is to gather all the necessary data to decide if the permitted total weight of timber transports can be increased from 60 to 74 tons at some point. And the trial, as I mentioned earlier as well, takes place in what was previously Hedmark fylke. This is now part of Innlandet, in 11 designated municipalities on the designated roadwork within that area. And also with this truck that you can see here, the 9-axle truck, 24 meters long, needing a span from at least 20 meters from the first to the last axle. And since then, the trial has also been expanded to encompass 2 8-axle versions of 68 and 65 tons. Status, as of right now, the trial was set to start in July originally, but we realized sometime in the early spring that when we already had, most of the participants already had their vehicles ready to go, and also that we would need some extra time to figure out a way to handle, both to collect and handle all the data that we knew would be getting in during the trial. So to avoid having this eating into the actual trial period, we had a pre-trial or a pre-pilot or whatever you want to call it that ran from April till July. And then the trial itself officially started on July 1st. Still have the same 4 transport companies that are participating. One more is in the process of signing on now. We have a few more vehicles now than we had when we started, and a few more will probably be added early next year. The trial is set to run until July 2024, and the permits are valid to July 2026. Just to show you something kind of fancy. The trial area is, as I showed you in those designated area, we also have an online map that shows all the routes that are part of the trial, which is handy for the transporters. And also, because this is a dynamic map, we also have the possibility of removing roads if they sustain too much damage, or if we need to implement restrictions due to severe weather conditions, roadworks, or anything like that. This can also be added to this map. Now, as part of this project, in addition to collecting the data from the vehicles and looking into their impact on the road infrastructure, there's also quite a lot of other interesting research going on, especially looking into the impact from heavy goods transport in general and their impact on road infrastructure, and how to use different forms of technology and different methods to monitor that impact, which can then be used both in later pilot trial projects like this, and also to more accurately estimate traffic loads in the future, which is very beneficial in a lot of ways. The data collection from the vehicles, we're collecting quite a lot of data, which is, I'm not going to read this whole list here, but this is ideally all the data that we plan on. We're connecting some of it now, and a lot of it, and what we're not collecting now, we're still trying to figure out how to collect later. And yeah, it's a very big list. And in fact, it's so much data and so complicated to both collect and to, not to mention actually aggregating this data, that we have brought on a consultant or a consultancy firm to handle this part of the operation for us. They are using a cloud-based brand neutral solution to handle all this data. And it would need to be brand neutral because the vehicles participating is from, we have 2 different motor vehicle manufacturers and a lot of different trailer manufacturers. So we need a system that can handle the data coming from all these different vehicles. The data flow within this system is that it gathers the data from the vehicles and also the machinery on board the vehicles through the fleet management systems from the manufacturers, as well as data from third-party sensors. That's then uploaded and analyzed in the cloud and then presented in this online format. And the flow, as you can see here, is fairly complicated, again, because we are dealing with data from a lot of different manufacturers, and also data is defined and tagged differently, and also the time slots are very different. So in order to get something you can actually use, it requires quite a lot of working and analyzing in order to get it into a format that actually makes sense, and then that even more so can actually be presented. And when it's presented, it could look like something like this. This is a map solution, is still a work in progress, but as you can maybe see, maybe it's kind of tiny, but maybe see, we are logging a specific vehicle combination that is going about during the course of one day. All the brown lines is position, and it's gone about, I think, 4 or 5 round trips, as well as some additional detours. And every single needle or point in that map, you can click on it and you can get a whole lot of data. This image here shows the axle loads and the total weight, and I think also tire pressure, but there's really no limit to the amount of data from the sensors that you can add to this. And you can also add any data that you want from, you can also add road data. So you can, in addition, you can see, for example, if there's an incline related to vehicle speed or a lot of other, you can pair that data to get a lot of value out of it. And data could also be presented in graphs or any other format that makes sense relating to what it is you're trying to communicate. Again, they've just demonstrated a bit more how they can use all these more forms of data. And they've also asked me to point out that one type of data that we're currently not collecting is data from stability sensors. So they're now looking into finding a way of if they can do this by third-party sensors as well. And stability especially is important because, yeah, well, as you can see in the pictures, there's quite a height difference between the 60-ton combination and the 74-ton combination, which will give you a very high center of gravity, which increases concerns. I'm not going to necessarily say increase the risk, but very much increases the concerns about overturning, about swerving, about heeling, which is one of the deciding factors when we are going to evaluate the traffic safety. So again, ideally, they would like to get this data from the fleet management systems or from the vehicles directly. If that's not possible, they could retrofit various forms of systems. And what they're also planning to do, they say lab tests, but I think it's more like tests or experiments in a controlled environment where they have one specific driver and a road that fulfills a set of criteria, especially to eliminate that when it comes to stability, driving style is a pretty heavy factor. If it's a careless driver who's driving quickly, turning quickly, all sorts of things. So in order to get the actual data on this, they would also like to do these control tests. And then also ideally in cooperation with the vehicle manufacturers. So that's where we are with that. Another, or rather an experiences so far, I think I told you last year that we were doing a load bearing capacity test, which we did in October, which was on a dry day. It hadn't rained for weeks, the optimal driving conditions. And what they actually found back then was that the 74-ton combinations with 9 axles were probably better for the road than the 60-ton combinations with 7 axles. Any damage, and though there was a question is whether or not the damage from the 60-ton combinations was more like, again, due to driving style than the actual vehicles themselves. But when they repeated this experiment during spring thaw, and I think they managed to select probably the worst day of the year to do this, which were the best, depending on how you define it. The first thing that they noticed that they were expecting to see was the pumping effect, where the water is sucked up into the surface from the passing of consecutive axles. But even more so, the road was actually completely destroyed after only 2 laps with all the vehicles participating, and they have to shut the experiment down. And they're now project is now arguing with the county of who's going to cover the repairs of that road. So yeah, quite bad results from that. The jury is still out on whether it's 74 tons combinations is actually worse than the 60 tons combinations of this. The project group is working on the report, and it should be published with the conclusions in not too long from now. But what we can conclude is that the load bearing capacity of the road varies both from area and with weather conditions. And it's essential to find a way to manage spring thaw if 74 tons is going to be rolled out in any kind of, if it's going to have any kind of road network to have this on at some point. And also in any other discussion about increasing total weights, otherwise the road is just going to be completely obliterated. So we need to find a way to handle this that also doesn't impair the efficiency of other goods transport. So that's kind of a headache that we're going to have to start to look into next year. And just a couple of final observations. One of the things we've noticed, we thought that the hauliers would jump at the opportunity to use the 74-ton combinations, but what we're actually seeing is that we have 2 out of all the combinations in the trial. We have 2 74-ton combinations, and the rest are 68 or 65-ton, and they seem to especially favor the 68-ton combination, which is something that we, when it comes time to evaluate the whole thing, looking into whether or not actually 74 tons is necessary, or maybe we can make do with 68. No conclusions there yet, but it's something to keep in mind. And the other thing is that another thing that keeps popping up in discussions, I'm going to say it's something that we've experienced so far, but it's something that keeps popping up in discussions, is whether or not the load securing requirements, which are good enough when you get loads of that size. So that's probably something that's going to be added to the trial. And they're going to hopefully, or maybe experiment a little bit, of trying to find out if today's requirements are good enough, or if we need something stronger, if this is going to be rolled out on a greater scale. So yeah, that is pretty much where we are at the moment. I've also added a link to the website for the trial. Most of the information there is in Norwegian, but most of the reports and things at least have summaries in English, if someone has any interest in that. So yeah, thank you.
Thank you, Elin. We have time for a short question. Is it any question from the audience here? Lennart?
Thank you, Elin. Have you had any border crossing with your 74 tonners into Sweden, or Swedish 74 tonners included in the test into Norway?
We advertised participation in the trial in Sweden as well, because I think at least there's a couple of BK4s going into the trial area. But we didn't get any applicants from Sweden, but they were invited. And I don't think that the Norwegian combinations are going across the Swedish border. At least I'm not aware that they do.
Thank you. Otherwise, I would have a question. Do you think it will be introduced after this? What do you think the political opinion? Are they positive to this or negative that it will be introduced after the period and the test period?
Well, the assignment to have the trial was originally initiated from the politicians, so I think they would be interested to have it, but I'm not sure they would want to have it at any cost. So we will need to see what the results of the trials are. And we also know that even if we're going to have it, there will be bottlenecks, and it may not be suited for every part of the country.
No. Oh, thank you. And thank you again, Elin. And we will also have a speaker once again. So please, Martin, now we will hear more about what you're discussing to have greener vehicles on your roads in Denmark.
Thank you. Okay, now back again as Elin. Well, this I'm going to tell you about another analysis we are doing in Denmark. And whoops, was it the wrong? Like this? Wrong direction. Not going backwards. Right. Now, well, as for the DO2, this is caused. This analysis is caused by a political agreement last year. The first one was regarding the DO2 trailers, and now the second one is regarding an optimization of the national rules for weight and dimensions in Denmark. And the frame was that we had to look into different kind of actions which could reduce the CO2 reduction, but also look into, of course, consequences for infrastructure, bridges and roads, and economical consequences. So what we did was that we two parts. This means the Danish Road Safety Agency and the Danish Road Directive, where I'm from. We made an overall list of possible actions within the existing frame of dimensions in Denmark. And we looked into it and said, well, what could we do to make the transports more green, more effective, and give some incentive for transition towards alternative fuels or zero-emission trucks. So we made this list, and we invited the branch to discuss this with them. And of course, they also had a lot of proposals for this list. And we combined the total list and prioritized the list and estimated the number of trucks for these actions. And we also had the branch to help us with this because looking into the future is very difficult. So we said, if we asked the branch for this action, how many trucks do you think would be realistic for this introduction? So that has also been a part of the analysis to make sure that they had some potential at all. So the frame was, for these actions, all of them should be able to go on the entire road network. It's not like the EMS; they are also only granted for designated routes, but for these trucks, they should all go on the roads in Denmark, and they must be able to comply the rules for type approval from the EU, and it must be able to control them by roadside controls, and of course. Not all actions have a CO2 reduction, so it's it was very necessary to look into if this action has no CO2 reduction. Well, it's not. We cannot use it, or we have to balance it, of course. So that's why we prioritized these actions. So now I'm going to tell you about. We made up a list of 24 different actions. And at this moment, we are analyzing all of them. We're not completely finished yet. So the first one, or the first couples, are that if you, for instance, have a rigid truck or road train, and the haulier would like to put on a concrete mixer or a crane, which is working with a battery. The battery is much heavier. And if the haulier needs to put on a battery on the truck, then he get a reduced load permit. So we need to have a kind of incitament to have a higher total weight. So we look into having up to 1,000 kilograms extra if there's a battery on the truck to drive the concrete mixer or the crane. And so we also look into having an increased weight for all trucks, trailers, and road trains if they have alternative fuels or zero emission. You might know that in the EG directive, there's a possibility for 2 or 3 axle trucks to have 1,000 or 2,000 kilos extra. but we look into having all kinds of trucks, 4 axles, 5 axles rigid trucks, and all road trains to have this extra 1,000 kilos or 2,000 kilograms. And a third one is to increase coupling length for a tractor with a semi-trailer. Normal EU combination is 16.50 meters. We look into 7.5 meters. Of course, the trailer is still 13.6 meters, so the extra meter is allowed when you have to go with a gas tank or a hydrogen tank or anything that uses more space on the semi tractor. So you need an extra space, an extra wheelbase to have this gas tank, or if it have more space, it needs more space than a diesel tank. So that's the constraint, that for a meter you need to go with alternative fuels or zero emission. Another action is to look into more heavy rigid trucks. In Denmark, there's a rule that a 4-axle or 5-axle or 6-axle rigid truck must be only 32,000 kilograms. So an action is to look into 34,000 or 35,000, or allowing a 5-axle, which may only be 32,000 kilograms. Can it be 40,000 kilograms, or could it be 42,000 kilograms? That are we looking into. Of course, there's a kind of minimum axle wheelbase that we have to look into to be able to go across all bridges. And we also look into flexibility for the trailers and trailer after rigid truck. What would be able to have more weight for the trailer if there's a twin tire on the front axle, or can we also have a 5-axle trailer behind the rigid truck? But there's a limit, because the maximum weight for a 7-axle road train in Denmark is 56 tons. So if the haulier would like to increase the weight of the trailer, he cannot go further than 56 tons of the entire road train. So it's a kind of flexibility action for the branch. And so we also look into different kind of effectiveness. In Germany and in Sweden, they have longer trailers, and also in Finland, and we look into that as well, going from 16.5 meters to 7.8 meters, which may mean that we have extra 8% loading space. And we also look into if there's increased possibility for increased length of the semi-tractor and the trailer. If you have a crane, normally if you have a road train and you have a crane on the semi-tractor, you lose space on the trailer. But by extending the whole length of the road train, you can have a crane as well and have the same load space. So that was the 24 different kind of actions that we're looking into and analyzing. But we also need to find out what are the amount of trucks today and see what are the possibilities. So out of 40,000 trucks in Denmark, how many of them could go from, or how many of them have a potential in this? So that's why we asked the branch and estimate these figures. So, yeah, that was about it, I think.
Thank you, Martin. So, also here we have time for questions. Is it someone from the audience or online? I will try to also check immediately online if there is any. Advice, have you also, you said you had discussed with the branch, which type of these trucks are they interested in? Do you know? Because you showed, was it 20 different?
24
different.
Yeah. They are, the branch is interested in all.
Yes.
So of course they can see a possibility in effectiveness and flexibility, of course. So that's well, but also they can see the way moving to the green transition, transition. Sorry. Yeah.
Yeah. So if they are allowed to use this, it will go faster.
Exactly.
Yeah. Can you, Lisa? Take it now. So Lena Larsson, Volvo.
We are right now looking at 5-axle trucks in Sweden for city applications. So we are discussing internally in Sweden. I have discussed with Otto and with our Finnish organization also. So if you are looking at it, I think it's good if we look at it together, because I think the Finland is a little bit ahead of us, so that we get practical 5-axle trucks.
Okay. Yeah. Thank you.
Yeah.
Let's
yeah. Sorry. Let's continue.
Nice. I'm just saying that we can use this analysis across borders. Yeah.
Yeah.
Exactly.
I also saw it was quite big. Were you going from 32 to 40 ton, 8 extra ton, like 25% extra?
Yeah.
It was quite big.
It was
change.
No, for 4-axle it's going to 35 tons, and for 5-axle from 32 to 40 or 42 tons. So that's quite an increasement. Yeah.
Yes. I think, wait, Lena, if you want to say something, because otherwise we don't hear who are online.
I try to make a mapping of how you can use 4- and 5-axle trucks in different countries, and it's not so easy because in most countries there are no axle wheelbase demand. So we have to guess. So we look into how they are built more and look into the build system and see how they are built. But it's really good if we can have some. So maybe we should do some NVF report on this or something.
Okay. Yeah. We're going to define the wheelbase minimum because of the bridges. So.
Sorry, Lisa, one more from Finn.
Jeg lige tage det på skandinavisk. Vi er jo det eneste land i Europa, der ikke har... Vi har godt nok krav om, ligesom de andre lande, med 6,20 meter for 32 tons, men vi har dispensation i Danmark for det. Bare der er 2 styrende foraksler, så kan vi godt have kortere hviler. Så der falder vi lidt uden for de øvrige. Men det er jo klart, at hvis vi skal have 5 aksler, så kommer der nok en eller anden grænse for, at de skal have en vis længde for, at de kan køre på over 35 tons totalvægt. Så vidt jeg har forstået.
Yes, exactly.
Men altså, vi falder lidt udenfor, fordi vi kan godt have meget korte 4-aksle biler i dag, som er 32 tons, som overhovedet ikke må køre i Sverige og i Norge.
Exactly. But it's because of the bridges that we are looking into a minimum wheelbase.
I have one question from online. Are you using PBS standards in your study? We use them, and it was very popular. I think it's a question from Alexandra from Argentina.
Okay. No, we're not looking into PBS, not yet, but it looks like we're going to sometime, I think.
She also thinks it's a very interesting presentation you did.
Okay.
Very good.
Thank you.
Yeah, but thank you, Martin. Now we will have next presentation from Jenny Lundahl at RISE, so it will be online. Hello, Jenny. Anna, we heard about experiences from Intelligent Access in Europe or also Australia before, and now we will hear about some projects which has been ongoing or are planned in Sweden. So please, if you can show your presentation so we can see it, that it works.
Yes, and you can hear me?
Yes, we hear you clear.
Very good. Oh.
Yeah, now we can see it as a right mode. So perfect.
Okay, very good. Yes, this is a brief overview on pilot projects around geofencing and intelligent access in Sweden. My name is Jenny Lundahl. I'm a senior researcher and legal expert at RISE. Very short on geofencing. Geofencing defines a digitalized geographic zone where the characteristics of vehicles can be stipulated, such as speed and whether they run on fuel or electricity. And it is also possible to designate that only authorized vehicles may be driven in the area. I'm only involved in 2 of the projects, but I have put contact information on each slide. The project Smart Urban Traffic Zones puts the people in focus. This project comes from the Research and Innovation Program for Geofencing in Sweden. And the project idea is that such zones based on geofencing can be a powerful tool to contribute to quieter, safer and healthier environments. And the project includes physical tests in Stockholm and Gothenburg. One test is about adapting the speed to the number of unprotected road users in the area. And another test is about changing the drive line and regulating the speed for the vehicle to access driving in certain areas. And I think this could be the most interesting test for this conference theme. At lower speeds, the road's bearing capacity increases and then the trucks can have more load without negative effects. So that will be tested in the project. And also there is a test about sending warning signals to vehicles and unprotected road users around construction site exits to prevent accidents. And the project has a broad network of participants included. And you saw the contact information if you need more information, I hope. Another project, GeoSense, is about geofencing strategies for implementation in urban traffic management and planning. The project elaborates on geofencing solutions aiming at improving traffic flow, safety and air quality. And the project will design, trial and evaluate geofencing concepts and solutions for specific cases in cities. And these cases are being formed at the moment, not really final. And the project will also propose new ways of successfully deploying geofencing technologies. And it's a EU project that gathers project partners from Germany, Norway, Sweden, and UK. And you have the contact information on the slide. And I'm not sure really, I wasn't able to listen to the conference today, and maybe you have heard something about this project. It's a case study on excavated materials in cities, pilots and system analysis. The project started in April and study how the high capacity transport concept can be applied in cities. And the hypothesis is that it will improve both productivity and transport efficiency, as well as reduce emissions. And the project will also study digital access control and tools such as geofencing in order to control speed and routes. And you have the contact information on the slide. And the Nordic Way projects 1, 2, and now 3 are a collaboration between public and private partners in Finland, Norway, Sweden, and Denmark. And Nordic Way 3 has more cities involved, and it builds on the achievement of the previous projects. The project focuses on the digital ecosystem, and several geofencing concepts are being tested. The services enable vehicles, infrastructure, and network operators to communicate safety hazards and other information from roads in the Nordic countries between different stakeholders. And this project was recently completed. It studied the process of granting exceptions to the traffic rules for abnormal vehicles, vehicles that are too wide, too heavy, or too long to be driven on public roads. And the focus was on increased digitalization and improved legal processes. And as a result, several proposals for improvement measures were submitted for consideration. And here you see a picture of the report. It has a summary in English also. And you have the contact information if you need more information. And here are my contact information. If you want to reach me, I can send you to or set you up with the right persons if you need more information. So it was very, very short.
Thank you, Jenny. Yeah, I think you were really quicker than expected. But maybe I can add something because Fredrik Cederstad is in the room, so maybe you can raise your hand so people who are in the room can see who is responsible for this high-capacity transport city we talked about. Oh. And I can also add about this DigiDisp that we plan to have pilot projects for that included in Nordic Way, so it will be some sort of continuation both for Nordic Way 3 and this DigiDisp. Then I ask you one question, Jenny. What do you think, because about this, the legal barriers are always a big issue when you talk about intelligent access, and also what we had Luz Arts talking about earlier this morning. What do you think are the biggest legal issue against being able to implement intelligent access in a more wider, broader perspective?
Yes, I can start by saying that I didn't mention that during the presentation, but I recently worked with an investigation on automated driving and geofencing at the Ministry of Infrastructure. And the report from the investigation deals with the liability issues and some new legislative proposals. And one proposal is that the municipalities should be given a mandate to provide special traffic rules for vehicles that apply geofencing to meet certain conditions. And the proposal also includes some definitions on geofencing. Unfortunately, the report is in Swedish and has no English summary. It's on consultation right now till 20th of December. And we will see what happens next, if there will be a new legislation on geofencing and automated driving in Sweden. And we did a little summary on legal aspects and barriers in the report. And we saw that one problem is that most vehicles lack geofencing technology at the moment, and there are no harmonized standards for the technology. And we also saw that mandatory requirements for certain technical equipment in the vehicles can have implications for free movement under EU law. EU law also has a ban on discrimination, and I have worked with legal aspects of distance-based tolls a few years ago, and there are similar aspects to take into account, and often foreign vehicles must have some sort of separate solution if some equipment is mandatory in the vehicles. So those are some legal barriers for a broader implementation, but there are also implications under privacy and GDPR also. So if you want to follow up if you want to follow up, for example, if a transport is legal or not, if you override the speed limits, etc., it could be a problem according to GDPR to collect that data. So there are some legal aspects in this area.
Thank you. Maybe Jenny, I shouldn't have asked you, because now everyone thinks just it's a lot of barriers, because I think it's a lot of drivers also for this. But now I think we have more questions here, so I shouldn't ask more. So please, Fredrik. So please present yourself also.
Yes, Fredrik Cederstad here. I'm coordinating the HCT project, as you mentioned there. I just have a question on geofencing linked to the ISA regulation. I think it's coming next year in Europe. If that can open for a standardization of possible geofencing in the future, or do you have a clue of that?
ISA.
I think it's called Intelligent
Yes.
Speed Advisory.
Yeah, of
Yeah,
course.
so
There are some differences between ISA and geofencing, because ISA, according to the EU standard, it's about following the speed limits, and geofencing could be another speed limit that is not according to the traffic legislation. It could be a lower speed, more like a recommended speed. So that's a difference. And also it could be a difference also since the EU standard include 4 different methods, and some of them are only informative or advisory for the driver and not mandatory, so to say. And some geofencing solutions are more mandatory, or at least automatic. The driver can maybe override the functionality, but it's automatic. So when you enter the zone, the vehicle automatically reduce the speed. But according to some ISA methods that the EU standard include, it could be only information and warnings, haptic and auditive signals to the driver. So it's not really the same thing. Sometimes you can achieve the same goal with ISA and geofencing, but sometimes you cannot achieve the same result with ISA according to the EU standard. And I have a contact with UNEC about harmonization on vehicle regulations, and they say that at the moment there are no regulation on geofencing in the pipeline, but that could be changed in some years. But it's dependent on how on what type of standards the vehicle producers want to have also. So, and Sweden, for example, could strive to put that in motion, that we want a geofencing technology standard for the future.
Thank you. Now I think it's time for coffee break. So also you online, we will be back 2:45 in half an hour. So now we'll have time also for you to have a coffee or something, and we will have coffee outside, I believe, not at the same place as lunch.
Thank you everyone for receiving us, for giving us the opportunity to talk about our study here that we conducted for our master thesis in logistics at the Handelshochschule in Gothenburg. Ricardo and me and my partner Franca are gonna talk about our study that deals with the intermodality use of HCT in the context of railroads transportation for pre and post haulage. So let's get to it. So we conducted our analysis in the Swedish market to analyze the potential for extending the current regulations that are in place in Sweden from the current 3 TU capacity to 4 TU capacity, which essentially deals with having trucks transporting 2 40-foot containers in complementing with the rail transportation. So our study had partners from every major logistics providers in Sweden, from every also terminal providers that helped us with the insights that we wanted to get for our study. So basically the 3 main questions that we had in our study were first of all, analyzing the possible barriers and obstacles that are in place for a nationwide implementation of the HCT in Sweden, and what could the obstacles be, whether they were more in a perception-wise or in a operation-wise for a further extension of these regulations. And we also wanted to identify possible transport corridors that would be beneficial for applying these extended regulations, because it's not every corridor that can produce benefits. You have to have corridors with constant and higher flows of products in order to get high fill rates. That's something that previous studies have shown, that in order to get the benefits of HCT, you have to have higher and constant fill rates. So we wanted to identify these corridors. And we also did a cost analysis to come up with the potential cost reductions and emission reductions that could be observed in these corridors that we identified with our partners. And on the left, you see the map of the terminals that we interviewed for our analysis, because we wanted to understand from the terminal's perspective as well, not only the logistics provider's perspective. So we wanted to understand if there was any major investments that were required in order to accommodate the trucks that have 2 containers, and if there were also salary and any other issues that were in place in order to accommodate to the needs of HCT. And the study assumptions that we had was that we would be talking about trucks with up to 34.5 meters in length. That means having up to 2 40-foot containers transporting the goods. And the goods would arrive at the port of Gothenburg in order to do the analysis of the cost reductions and cost analysis. We did the routes from the port of Gothenburg by rail to the rail shuttle to the nearest terminals, and then to the final customers that are logistics operators, experts identified as possible customers that would benefit. So we did the cost analysis together from the port of Gothenburg onto the terminals, plus the HCT for the pre and for the post haulage, and we also employed the distances from these from the port of Gothenburg to the terminals, and then the final customers, in order to make the calculations to identify in the identified corridors that our interviewees had identified for us as possible customers that would benefit from the exemptions. And we did then the cost analysis comparison of both scenarios, having the current regulations that are in place in Sweden that allow for 3 TEU capacity trucks to transport in the roads. So we did that comparison versus having the scenario of the extended regulations with trucks with 4 TEU capacity, and then we compared both to see whether there were cost reductions and also emission reductions that would be observed.
Yeah, so now I will continue with the results of our study. So through the interviews that we had with the logistics service providers and with the terminals, we were able to identify a few barriers that are currently hindering the implementation of HCT connected to rail transport, as well as some operational improvements that the study participants could foresee in case HCT would widely be allowed in connection to rail transport. And overall, we can say that most of the study participants could identify suitable freight corridors in their current operations that would be feasible for HCT solutions. And also the logistics service providers mentioned that they would be ready to start off the operation with HCT vehicles. However, there are a few barriers in place right now. So one of the main barriers is the bureaucracy, that there's no national regulation for HCT vehicles in place yet, which means that they always have to apply for an exemption at the Swedish Transport Administration, and that can take quite some time until it is granted. And the same also goes for the opening of new railway tracks, since one of the main goals with intermodal high capacity transport is to shift more freight from road to rail. And in that case, the railway infrastructure needs to be developed as well. And that needs to be deregulated by the Swedish Transport Administration as well. Another issue is that most of the roads would need to be classified as bearing capacity class 4 roads in order to be able to operate HCT vehicles. However, in that sense, we could already see some improvements throughout the past years, since more and more roads in Sweden are already classified as BK4 roads. And then especially some of the northernmost terminals mentioned that the road network is not optimal yet, since especially some of the municipal roads have quite a low standard, and that could be an issue if longer vehicles want to operate on these roads. Then when it comes to the operational improvements, most terminals mentioned that the operation of HCT would lead to less congestion around the terminal, since there would be fewer vehicles in circulation. And that could also reduce the potential amount of accidents and also lead to a better air quality if you have less vehicles with less emissions. Furthermore, the overall terminal flows could be smoother. That also refers to the on and offloading if you have to concentrate on less vehicles. And then most of the participants mentioned that the greatest benefits would occur for large customers with steady volumes, since they can, even with HCT vehicles, achieve a high fill rate and thus decrease their costs significantly. And lastly, the operation of HCT would require less drivers for the same amount of goods being transported, which is good since we are currently also facing a lack of truck drivers. Then we did the cost calculations, as Ricardo before mentioned, and therefore we used the transport corridors that the terminals and logistics service providers could identify as feasible for HCT, and we also used the currently yearly transported capacities on these corridors. However, we had some missing data, so we could just do the calculations for a few of the investigated relationships. However, we ended up with average cost savings for the PPH distances of 13.7%, which is quite a good amount. And then we did the calculations for the overall IRT chain for the terminals where we had enough data, and these results are presented here on this slide. And one of our conclusions was that the cost savings are the highest in those cases where the PPH costs are relatively high and the railway distance is relatively short. So if you compare the results of the terminal so our overall conclusions are that most terminals and logistics service providers were able to identify suitable freight corridors in their current operations, which would be feasible for intermodal high capacity transport. So we can definitely say that there is a market potential for intermodal high capacity transport in Sweden. And then even though there are a few negative effects associated with intermodal HCT, and there are a few investments that would be required in case HCT is widely being implemented, these negative effects and investments are merely marginal, and the operational improvements, as I mentioned, and also the cost reductions are much more significant. Yeah, and as mentioned before, we can reduce costs, operational costs, as well as emissions through the usage of HCT vehicles. And yeah, we also did a brief calculation of emission reductions for the investigated relationships with a scenario of 3 TEU compared to the transport of 4 TEU, and ended up with average emission reductions of 17%. Yeah, so these were basically the results of our study, and thank you for listening.
Thank you. Is it any questions to Franca or Ricardo? I think it's really interesting. I will just see if there was something online also. Sorry. But you said that it was bureaucracy and road network and other things which were barriers. They didn't say anything about economical or other issues, because we have in reality had problems to find these projects. So, but what did they say otherwise when you interviewed people?
Yeah, some were worried that there could be a higher competition between rail and road, even though in case, if it's implemented in a good way, then yeah, you could shift more freight from road to rail, which would be the aim. But then, yeah, it could also be an issue to develop the railway infrastructure fast enough for higher capacities. Yeah, because there's also an issue of bureaucracy.
Yes.
Yeah, but most of the interviewees were optimistic about the perspective of having enough customers that would justify having the demand and to implement HCT.
Thank you. Thank you again.
Thank you.
And good luck also in the future. I know you're back in other countries.
Thank you. Thank you so much.
And we will hear more about really interesting things of what you think, Otto, with vehicles and intelligent boogies. Yes.
Okay, my name is Otto Lahti, and I come from Finnish Transport Agency, and I have been working about 9 years now with heavier and longer vehicles, and I've been working mostly with our national rules that enables these bigger trucks in the traffic. And shortly, why...
Ursäkta Otto, den hörs inte längre, så du får ta den här. Sorry. You need to take this instead.
Okay, now you can hear me better. Yes, so why we to use these high capacity trucks part of the traffic, and the main reason is that everything is ready. So when you want to get more efficient transport, there is possibilities with electrification and automated trucks, but we have to wait quite long that those are part of the production in a big picture. But the trucks are completely ready, and the trailer development is also ready when you just choose the right trailers, not the cheapest standard trailers in these purposes. And quite often the biggest problem is that you don't develop the trucks and trailers, you just test them and see what the problems are. But in Finland we have quite many medium-sized trailer manufacturers, and those have been developing these products quite long. And also the biggest manufacturers like Smith and Casper have been developing trailers now. And those little bit more advanced trailers solve most of the problems that we have with high capacity trucks. And the basic problem in Nordic conditions is that it's really difficult to find optimal balance between the high speed, stability, and good traction in winter conditions, and then also agility, driving lines in a low speed. So how to find the balance that it's safety in a high speed, but also enough agility in a low speeds. And it's really, when you take a longer wheelbase, you get more weight on a truck, you get more stable combination, but at the same time you need much more space in a tight turns. But there is a solution for this, or actually two solutions. And when you combine these, we call that the intelligent high capacity bogie. And on the left side picture, you see a traditional bogie that have been used in Norway for a really long time. So a little bit longer wheelbase and then steerable last axle. So that is the first key solution to make these trailers better. And the extra price for that is not so high as many people think nowadays. Then the other possibility is what they call is a turning assistant. And the idea is that you reduce the spring pressure at the last axle, so you're actually virtually changing the turning point at the bogie. But the problem is that at the same time you will reduce the kingpin weight, so you have less weight on the tractor. And that's a problem in a winter time because you need a lot of weight on a driving axle and a steering axle in those tight turns. So you can't use that simple turning assistant in that way in winter conditions. Okay, but when we combine that, we used steerable axle on the last axle and then turning assistant in the middle. Actually, the turning point will be at the first axle. So the central gravity point and a turning point is now about 1.3 meters from each other. And that makes the same trailer that it's really stable on a high speed and then also really flexible in the low speed. And these are two simple products that can be combined in this way. And what it means then in a turning circle, I will present that next. So in the first time, this was tested in this truck. This started in a traffic about 5 years ago. It has been traveling more than 1 million kilometers now between Jyväskylä, so central Finland, and Rovaniemi, which is at the Arctic Circle. It's the most northern city in Finland. So it takes that about 600 kilometers north every night and then 600 kilometers back every day. So it's in a really high productivity use. And the difference is that, or the idea is in this case, which was the first time when this kind of bogie was used in an A-double, that the wheelbase is about 0.5 meter longer than in this Swedish Duo 2, which makes it brings then more weight on a tractor. It can manage in the winter conditions much better now, and it can tow almost any kind of standard trailers. And the next development is that we have this kind of intelligent bogie in both trailers.